Right, Lamay. Right. Good afternoon. Hi, bud. Uh, Hari. Clear, eh? Uh, right. Mang, I believe the people who are in the live can properly hear me. You have this ask from NJ or whatever the group, you can respond. Can you hear me properly, Lamay? You have the thumbs up option as well. Okay. Right. May Lamay, right. For first few weeks, hearing double. It's too much, I guess. Adu karanne oda. Right. May but live එකේ ඉන්නයි කියන්න. Can you hear me properly now, Lamai? Is everything okay? You are supposed to drop me messages there in Ask from NJ group. Okay, fine. Right. Right. Hari. Lamai, it's like this. Last Wednesday we started, ned? Abi last Wednesday tamai පටන් ගත්තේ. I mean, for first few weeks I'll be using both the languages, right? Right. For my theories and all, I'm using only in English, but for second explanation, I'll use Sinhala to most of the guys to get familiarized. You get the question of getting familiarized as well. So last Wednesday actually, which is 6th of March, if I'm not mistaken, 6th or 5th, whatever, we started our class, right? But it was basically O-level, the mole concept. We studied about the mole. The mole has to be known, has to be dealt with throughout the A-level course as well. So since most of the online people and the physical people, they didn't have their tutes, I did a extra lesson about O-level revision. But from today onwards, our time slot is fixed, right? From today onwards, we'll be working every Friday, 2:30 to 5:30. Once your schools are started, if you want me to shift this little bit downwards, I would say 3 to 6, like, just let me know if it is more comfortable for the physically coming people. I can shift this down 3 to 6. Anyway, it's Thursday, Friday evening session. I'll be allocating for 2028 English medium class, right? So everything is fixed here onwards, and I'm starting A-level syllabus today itself, right? Right, it's like this lamai. අද දවස වැඩ කරන්න මම අද ටියුට් පැක් එක ගන්න නැති අයට a little tute will be distributed. මම හිතන්නේ physically ඉන්න කෙනා හැමෝගෙම අතේ ටියුට් පැක් එක තියෙනවා, right? You have it. For the online people also, in your WhatsApp channel lamai, there's a drive link where you can get download the first, for today's academic material. The first chapter of the first lesson can be downloaded there. But anyway, you have to get the tutes. Everyone will be settled with the tutes by next Friday, right? You must be having your tutes in hand next Friday. Today onwards, we are starting our lessons. I'm giving you the first homework today also, right? So you must be getting these three materials. You must be getting these three materials. Right? Past paper question book, which is known to be PPQ book, which covers past paper questions from first lesson, which is atomic structure, for last 25 years, from 2001 to 2025. So there's a workbook which contains about 400 questions from first lesson, right? This has, I would say this has all the provincial papers and all the main school term test papers and all the questions from relevant English books and stuff regarding the first lesson, which is atomic structure. And this is our main material, the tute, right? Because you don't need to keep a notebook for my class. You can write tute itself, right? You can use your tute and write whatever the available void spaces and getting the note completed here itself. So that's more convenient for you, but I want little thing to be done, right? You guys have to stapler, I would say 10 to 15 half sheets or full scrap papers or whatever, and put that extra bunch of papers inside the tube, and same kind of papers, bunch of papers, placed inside this workbook and the past paper question book as well. මේ PPQ පොතේ workbook එකේ tute එකේ තුනේම මේ half sheets 10 15 clip කරලා තියාගන්න extra notes extra examples අපි කරනේවා එතෙන්ට ගන්න වෙනවා. හරි? හරි. එතකොට මේ ඔය ටික තමයි කියන්න තියෙන්නේ. So I don't want to drag my introduction and stuff bit more than this, because last week also I did a thing. People who didn't attend last week's class, last week එකේ ආපු නැති අයට, you have a dedicated WhatsApp channel for English medium students. අන්නේ WhatsApp channel එකෙන් ගිය සතියේ class එක මම YouTube දාලා link එක share කරලා තිනවා. As a YouTube video you can watch. හැමෝම මේක බලන්න. You have to watch those previous lessons and complete your stuff by next Friday, because today by next Friday you must be very familiar with our process and you must be dealt with our process, right? අපේ process එකත් එක්ක familiarize වෙලා අපි next Friday වෙද්දි වැඩ කරන්න පටන් ගන්න ඕනේ. හරි. එතකොට අපේ WhatsApp channel එකේ link එක, in every tute you have a dedicated QR code which represents the WhatsApp link of English medium WhatsApp channel, right? When you can scan it using your phone camera or whatever, then you will be directed to that particular WhatsApp channel. Hurry, so the WhatsApp channel eකට join වෙන්න, every notification, every announcement will be delivered there, right? So you have a dedicated Ask from NJ group which is a live chat, right? When I'm conducting live sessions throughout the course, throughout this 2 to 2.5 years, මේ අවුරුදු දෙකමාර පුරාවට විතර මම මේ live classes conduct කරනකොට Ask from NJ කියලා group එකක් තියෙනවා. ඒ group එකේ ඔයාට chat කරන්න පුළුවන්. live එකේ ඉන්න ඕන කෙනෙක්ටත් පුළුවන්, physically ඉන්න ඕන කෙනෙක්ටත් පුළුවන්. You can drop a message there, or else you can write something in a chat and send it in front. Physically ආයට නම් මට එහෙම උත්තර දෙන්නත් පුළුවන්. හරි? හරි. එතකොට ළමයි මම ඒක බලනවා. Let's say if you want me to explain something in Sinhala, you just drop me a message. Sir, ඒක සිංහලෙන් පොඩ්ඩක් පැහැදිලි කරන්න පුළුවන්ද? Likewise, if I give you kind of an example, right? You can drop your answers there. So actively use it. It's a live chat, right? It's a Telegram group. You download the Telegram app and get into those groups. So that group is very active, and our WhatsApp channel is very active for our announcements and notifications and all the stuff, right? And I'll be conducting my classes today onwards to cover up the first lesson of the subject, right? So first lesson now. I'm moving into the lessons now, right? So we are starting our business now. It's like this, Lamai. Listen to me. Chemistry has 14 lessons. I told you previous day also, we have 14 units to be covered, right? I'll be using a time span of 25 months. That's what I told you last week, right? Right, I'll be using 25 months. So this is my project. So all set 14 units will be covered in the time span of 25 months, right? 25 months. So out of these, first 3 lessons are very important, right? Unit 1 I'll be commencing today. Unit 1 අදින් පටන් ගන්නවා. මේ මාස 25න්, right? Out of these 25 months, 3 months will be utilized for this lesson. Unit 1 වලට මම මාස 3ක් ගන්නවා. හරි? These lessons are very lengthy when compared to O-level lessons. And you know, when it comes to O-levels, you had maximum duration per lesson which is about 1 month or so. නේ මාසයක් විතරනේ maximum drag වෙන්න ඇත්තේ lesson එක. නේද? Is that so? Answer me. Talk will you. Last week also I asked you guys to talk louder. I want you guys to talk very, very louder here, right? So it's like 1 month or so for the longest lessons, right? But here, මෙතන මේ first lesson එකම මාස 3ක් විතර ලොකු පාඩමක් තියෙන්නේ. Since this is very lengthy, what I have done is, anyway I have to tell you, I'll be giving you all the translated materials which I'm giving to Sinhala medium class. You know, my Sinhala medium class is well established, and we have thousands of students island wide and cities where we conduct physical classes. So same set of materials will be given. මම ඔයාලට Sinhala medium class එකේ materials ඔක්කොම මේ විදිහටම translate කරලා දෙනවා. They get this workbook, tute and the PPQ book. You are getting the same stuff here, right? So this is a very comprehensive course when you compare with other English medium classes, because you just see what I'm saying. Single English medium chemistry classes කරන වෙන කාගේවත් ලොකුවට single medium classes එක majority of the results නෑ. ඒගොල්ලෝ English medium විතරක් ළමයි ටිකක් තියන් ඉන්නේ single medium competition එකේ. They can't compete. It's like that. Right? But මම ඒකෙත් උඩම ඉන්න ගමන් තමයි මේක conduct කරන්නේ. So you are getting the cushion of getting the premium materials and stuff from me. Right? So I'm telling you, since this is kind of a lengthy lesson, right, I've divided this particular lesson into 10 or 12 small units. Those are said to be chapters hereafter. That's how I deliver my note. Right? So the first chapter will be started now. Right? So the first chapter of the first lesson, which is history of atomic structure. Right? History of atomic structure. Right? This is how I'm approaching the syllabus. Right? History of atomic structure. Right? Here we will dedicate 2 weeks for this and next Friday. These 2 Fridays will be dedicated to this chapter, right, where we study, listen to me Lamai, where we study what had been done previously. Now we are living in 2026, no, but chemistry is about 400 years old now. How old chemistry is? Talk louder. Come on. How old chemistry is? It's about 400 years old now, right? 400 years. Right. Out of that 400 years, we say the history of modern chemistry is about 200 years like. Right. Chemistry කියන concepts මුලින්ම ඇවිල්ලා තියෙන්නේ 400 years ago වගේ. But අවුරුදු 200ක් විතර chemistry කියන subject එක establish වෙලා නැහැ. Electron configurations, covalent bonds, ionic bonds, මේවා ගැන අපි කතා කරන the modern chemistry we are studying as at now has about 200 years of history, right? ඒ කියන්නේ 1800 වල විතර ඉඳන් වගේ තමයි 1800 1900 අවුරුදු 225ක් විතර තමයි modern chemistry වල history එක තියෙන්නේ. ඒතර මෙන්න මේ history එකේ atom එකේ structure එක ගැන මේගොල්ලෝ හොයාගත්ත දේවල්, right? Things that scientists discovered about the structure of atom will be discussed under this particular part. First 2 weeks of this 3 month will be allocated to this particular chapter, the history of atomic structure, right? So that is what I have to tell you. So we'll start our stuff then. අපි වැඩේ පටන් ගමු. Tute එකේ first page එකේ ඉඳන් we have to move on. Tute නැති අයට, online tute නැති අයට, you have the drive link there in WhatsApp group, right? So that you can download the PDF and keep it aside with you. For the physical people, you all have your tutes or temporary note or whatever, right? Raise your hands if you don't have your tutes or whatever. You have it, no? Everything is clear, right? Fine. Live එකේ අය පුතා, if you want to get the drive link for this PDF, for the first part, for today's lessons PDF, you can call us via our hotline, North 777 507750. You can contact us by calling this number. If you are calling us, we can send you the drive link so that you can download the thing and get in touch with us. Right. Anyway, we'll move with the note, right? Chemistry is the study of properties and behavior of matter. Matter is the physical material of the universe, right? Anything that has mass and occupies space is matter, right? Right. If someone asks you what is chemistry, now that is the first question that we have to answer when we are studying a subject, right? What is chemistry? Chemistry කියන්නේ මොකක්ද? Right. We say chemistry is the science which studies properties and characteristics of matter. The chemistry is the subject which is properties and behavior of matter. Properties and characteristics, properties and behavior, whatever, of matter. Hari. What is matter? You know those things from your O level, right? What is matter? Matter means something which has a mass and a volume. I mean, if there is something which has a mass and occupies a volume, which has a volume also, is said to be a matter, right? Mass එකක් තියෙන, volume එකක් තියෙන අයට තමයි අපි matter කියලා කියන්නේ. Matter exists in 3 different ways. What are the different ways of matter? Solid, liquid and gas. හරි. මෙන්න මේ matter එකේ behavior එක ගැන properties ගැන මේ study කරන science එකට අපි කියනවා the science of which studies the properties and behaviors of matter is said to be chemistry. හරි අපි chemistry කියලා කියනවා. Right, listen to me ළමයි. When it comes to old chemistry මම කිව්වේ අවුරුදු 400ක් 300ක් විතර පරණ කාලේ හරි එන්න history එකේ right when it comes to older days from older days onwards actually scientists they believed everything is built up on matter. කියන්නේ matter එකෙන් තමයි මූලද්‍රව්‍ය කියලා. those are said elements. Everything is built up with elements. Elements වලින් තමයි මේ solid state එකෙන් liquid state එකෙන් gaseous state එකෙන් තියෙන matter එක develop වෙලා තියෙන්නේ කියලා they believe to be. right? Elements කියන්නේ මොනවද කියලා එක එක definitions තිබ්බා. ඒතර අපි history එකට ගියාම history එකේ පරණම definition එක ගෙනල්ලා තියෙන්නේ Empedocles කියන කෙනා. right? We'll go with the note. Listen to me. Although material in our world vary greatly in their properties, everything is formed from only about 100 elements and therefore from only about 100 chemically different kind of atoms. මේ ලෝකේ දැන් කියනවා. අපි දැන් history part එකට යන්නම් බලන්න. Philosophers from the earliest times speculated about the nature of the fundamental components from which the world is made. Right. Empedocles believed that the four elements, earth, actually you would have said it as soil as well. Earth කියන තැන within brackets දාගන්න soil කියලා කියන්නත් පුළුවන්. Soil, fire, air and water made up all the things. Right. Puda, using my tools, I mean when you use my tools, you can take a red pen or a highlighter to highlight whatever the important stuff, right? You familiarize with your own way. I don't mind it. You have to come up with your own way. Right, highlight the name Empedocles. That is the first scientist, right? Who's the first scientist who came up for a definition for elements, right? Who came up with the definition for elements, which is Empedocles, right? Empedocles believed that the four elements, right? What are four elements? He told earth, within brackets you may write soil, right? Soil, fire, air and water. Soil, fire, air and water. Highlight karne vachana hatara. Right. Made up all things. Everything is built up with these four elements. That's what Empedocles said. The Hindus believed that the four elements stated above make up the world and space as well. As well කියලා තිබ්බත් කමන්නේ. Space කියලා විතරක් තිබ්බත් කමන්නේ. Space කියන වචනේ highlight කරන්න, right? So it's like this lamai. Listen to me very carefully, please. So earlier days, about 400 years ago, 400 or whatever the number of years ago, a person called Empedocles came up with the concept of elements, right? Empedocles stated the fact that everything in the universe, මේ universe එකේ තියෙන හැම එකක්ම හැදිලා තියෙන elements හතරකින් built up with four elements: soil, fire and water, air. හරි, soil, fire, water, air කියන හතරෙන් තමයි ඔක්කොම ටික හැදිලා තියෙන්නේ කියලා කියනවා. Soil, fire, air and water. Empedocles came පස්සේ මේ ලෝකේ Hindus were governing the world, right? Hindus had the domination of world ruling or whatever. When Hindus were dominating, they said, no, everything of the world is built up with five elements. Four of the elements were same as Empedocles, right? Soil, air, fire and water. The fifth one was the space. මේ තියෙන space එකයි මෙන්න මේ කියන elements පහෙන් තමයි ලෝකේ build up වෙලා තියෙන්නේ කියලා elements කියන elements පහක් ඉන්නා වගේ කතාවක් කියලා තියෙනවා. However, Democritus, right? Highlight the word Democritus. However, Democritus and other early Greek philosophers described the material world as being made up of tiny, invisible, indivisible particles that they called atoms, meaning indivisible or uncuttable, right? Right. Then came the word atoms, right? Then Democritus came up with the word what? Atom. Then comes the modern part. Little modifications are coming into play. Hindus lage era එකෙන් පස්සේ Greek era එකේ Greek scientist කෙනෙක් Democritus කියලා එයා කියලා තියෙනවා no, this is wrong, soil, fire, water, what the shit is this is not the elements, right? Every element is made up with very small, indivisible, invisible kind of a particle that is said to be an atom, right? So Democritus came up with the concept of what then? Atom. Firstly, Democritus came up with the concept of atom, right? That's how the atom concept came into play, right? However, Plato and Aristotle formulated the notion that there can be no ultimately indivisible particles, and the atomic view of matter faded for many centuries, during which Aristotelian philosophy dominated the Western culture, right? Even though during the Greek era, a scientist called Democritus came up with the concept of atom, it was pushed down, right? It was silenced during the Western era of Aristotelian culture. I don't know about history that much, but you would have learned history in your O levels, right? There you know what are the cultures and stuff, but that is not necessary. මේවා අහන්න exams වල. But anyway, Aristotelian era එකේ අර atom එක කියන concept එක අයින් වෙලා ආපහු අර පරණ fire, water, soil, air ඔය වගේ දේවල් වලින්ම තමයි නිකන් elements කියන්නේ ඒවා. ඒ වගේන් තමයි matter එක develop වෙලා තියෙන්නේ වගේ. They maintain that concept again. They maintain that concept again. But anyway, right? It was in 1808, right? That an English scientist and the school teacher John Dalton, right? You may highlight the word John Dalton, formulated a precise definition of the indivisible building blocks of matter that we call atoms. Dalton's atomic theory was based on 4 postulates, right? Then during the British era, a British person called John Dalton came back with the atomic concept again, but not like Democritus, right? Dalton came up with a comprehensive theory. එතකොට එයා නිකම්ම atom එකක් කියලා එකක් ගැන කියන්නේ නැතුව atom එකේ behavior එක, atom එකේ characteristics ටික පැහැදිලි කරලා comprehensive theory එකක් ගෙනාවා. It's said to be the atomic theory of Dalton. Dalton ගේ atomic theory එක කියලා තමයි ඒකට කියන්නේ. Right. It had 4 postulations, right? It has 4 assumptions, like I would say elements are made out of extremely small, indivisible particles called atoms, right? The basic definition, we know that, right? All atoms of a given element are identical in mass and size, but atoms of one element are different from the atoms of all the other elements, right? So he's coming up with something like this, Buddha. Democritus said every element of the world is generated from an atom. හරි? ඒ කියන්නේ එක atom වර්ගයකින් මම හරි atom එක කියලා නිකන් I would say නිකන් මම හරි small particle එකක් තියෙනවා. අන්න ඒකෙන් තමයි හැම element එකක්ම හැදිලා තියෙන්නේ කියලා තමයි අරු කීවේ. කවුද? Democritus, right? Democritus was talking about a common atom where every element is built up. But Dalton said something different. No. Everything is built on atom. Yes, atom is the basic building block of the matter. But each and every element has unique different atoms. I mean, an atom of nitrogen is different to an atom of oxygen. Both of those atoms are getting differed from an atom of hydrogen. Everything comes with atom, yes, but that atom, the unit, is different from element to element, right? That's what Dalton said. Further, he stated the fact that these atoms are combined with simple whole number ratios to derive more and more chemical compounds, right? And one more thing was also stated. These atoms cannot be destroyed or cannot be created during the chemical reactions. I mean, we cannot create atoms during the reactions. We cannot destroy atoms during the reactions. Right? These atoms are combined, the various atoms of various elements combines with simple whole number ratios to different compounds, to form different compounds. So normal දේවල් දෙක තුනක් කියවා. බලන්නකෝ යාගේ third assumption එක. Atoms of one element cannot be changed into atoms of a different element by chemical reactions. ඒ කියන්නේ atoms are neither created nor destroyed in chemical reactions. Compounds are formed by union of two or more atoms of different elements in a simple numerical ratio. Right? Dalton's atomic model is called, you may highlight the word, golf ball model. This is Dalton's model. This is believed to be golf ball model in chemistry. Right? අපි එතන එක sentence එකක් යටින් ලියමුද golf ball model කියන තැන යටින් under that within brackets you may write bracket ඇතුලේ ලියමු පුතා within brackets you may write හරි අරහන් ඇතුලේ ලියන්න this golf ball model this golf ball model this golf ball model this golf ball model is believed to be the basis of modern chemistry. මේක තමයි modern chemistry වල basis එක කියලා අපි සලකන්නේ. This golf ball model is believed to be the basis of modern chemistry. This golf ball model is believed to be the basis of modern chemistry. Is believed to be the basis of modern chemistry. The basis of modern chemistry. This golf ball model is believed to be the basis of modern chemistry. Hari, I'll give you 2 to 3 minutes. You read the subtopic simple A, introduction. A, left hand side එකේ column එකේ තියෙන simple A කියන topic එක කියන්න. You read the note. And if you have any single thing to be clarified or asked, you can drop a message there in Ask from NJ group. Physically ඉන්න ළමයි පුතා ඔයාලට මොනවා හරි අහන්න clarify කරගන්න තියෙනවා නම් either you can type a message and drop there or else you can write in a paper and send me a chit. I'll be reading chits as well. Right. Read the whole note will you? I'll give you 1 to 2 minutes. මම අද again මෙහෙම තමයි class එකේ වැඩ ටික යන්නේ. වරින් වර note කියවන්න study කරන්න වෙලාව දෙනවා. හරි? So I'll be giving you all the opportunities to carry on your work. You can't talk, huh? You have to read your notes and getting things well organized. Because I won't be taking too much of your time for life lessons and stuff. That's not my way. I'll be delivering high quality content and I'll be doing it very faster. I mean, only 25 months will be taken for 14 units coverage. Right, we'll move on. The main subtopic that we are allocating most of today's time is cathode rays and electrons. Right. So, we are studying the process of, the historical story of identifying electron. Then api kotana dinne? Then api inne golf ball model එකේ where everything is made from atoms. Atoms වලින් හැමදේම හැදිලා තියෙනවා කියන තැනේ දැන් අපි ඉන්නේ. නේ? ඩෝල්ටන් කිව්වේ එහෙමනේ. atom එක කියලා indivisible what do you call invisible චූටි particle එකක් තියෙනවා මේ ලෝකේ හැමදේම හැදිලා තියෙන්නේ මේකෙන් කියලා තමයි දැන් අපි දන්නේ. දැන් උතන තමයි අපි ඉන්නේ. දැන් අපි ඉන්නේ අවුරුදු 200ක් විතර පිටිපස්සේ 1800 ඩොලර් විතර තමයි අපි ඉන්නේ දැන්. ඒතර මේක ඇතුලේ electrons කියලා subatomic particles જાතියක් තියෙනවා. Atoms consist of electrons, protons and neutrons. Scientists identified these subatomic particles within a time span of 50 to 60 years. Again, 1850, 1860 විතර වෙනකොට they identified, no, atom is not the smallest particle of the universe. Atom contains three main subatomic particles, namely electron, proton and neutron. ඔන්නෝය electron එකයි proton එකයි neutron එකයි හොගත historical stories වල summary එකක් you have to know. In new syllabus chemistry syllabus එකේ you have to know that. ඒකේ electron එක හොගත historical story එක තමයි we are studying today, right? So we are studying about the discovery of electron, right? Cathode rays and electrons, right? Listen to me, right? By now means not 2026, I'm telling, I'm referring to 1800 like, right? By Dalton's period, what scientists believe kare everything is made with atoms kiyala subat me smallest particle ekkin thamai හැමදේම හැදිලා තියෙන්නේ කියලා they believe, right? They conducted several research assuming this. They assumed atom is to be the smallest particle and they conducted several research with the expansion of this subject, right? One person or one team or whatever, I would say one person, he observed that small paper particles can be attracted to a glass rod which is, I would say, brushed, which is brushed with silk cloth or whatever. කියන්නේ silk cloth එකක හරි අපි glass rod එකක් අරගෙන මෙහෙම හොඳට rub කරොතින් ඕකට චූටි particles absorb කරගන්න පුළුවන් වගේ observation එකක් atom එකෙන් තමයි මේ ලෝකේ හැමදේම හැදිලා තියෙන්නේ කියලා believe කරගත්ත ඔය ඩෝල්ටන් ගේ ඊරා එකේ 1800 ඩොලර් විතර එක scientist කෙනෙක්ට පෙවුනා. So you know the word, this is said to be what electricity. Hi, talk louder with you. Hi, කතා කරන්නකෝ please. This is said to be what? Static electricity, right? Scientists wanted to explain how static electricity occurs, but they failed. They couldn't explain how static electricity happens, having assumed atom is to be the smallest particles. So that gave them a little doubt whether atom is the smallest particle or not. ඒගොල්ලන්ට පොඩි doubt එකක් ආවා atom එකද smallest particle එක නැත්ද කියලා. මොකද they couldn't reason out how static electricity phenomenon happens. ඒක පැහැදිලි කරන්න බැරි වුණා. හරි. right. ඔය doubt එකක් තියාගෙන මේගොල්ලෝ shape එකේ ටික කාලයක් ඉන්නකොට, right, when they were carrying out their experiments with this doubt in their mind, another person who used a copper rod and zinc rod, right? Copper kurokui, zinc kurokui, copper rod and zinc rod in diluted sulfuric media, right? Diluted sulfuric media could see lighting up of a bulb. මෙන්න මේ bulb එක පත්තු වෙනවා කියලා observation එකක් දැක්කා, right? So this kind of apparatus, this kind of setup is believed to be an electrochemical cell. Am I correct? Electrochemical cell. So they couldn't reason out how electrochemical cells are operating, believing the atom is to be the smallest particle. මේ atom එක තමයි golf ball model එකේ කියන විදිහට ලෝකේ smallest particle එක කියන model එකෙන් මේ theory එකෙන් concept එකෙන් the operation of electrochemical cell couldn't be explained. Make explain karagannat barna. Static electricity wasn't able to explain. Electrochemical cell operation wasn't able to explain either. Right? මේ වගේම තව setup එකක් තියෙනවා where we can put carbon rods in a diluted sulfuric beaker and we can connect these carbon rod to a battery where we can see evolution of hydrogen and oxygen gases once the electricity is supplied, right? So that kind of process is said to be electrolysis. Am I correct? Right. So this couldn't be explained by means of atom as the basic building block or the smallest particle of the world. When we static electricity, electrochemical cell operation, electrolysis කියන process තුන පැහැදිලි කරගන්නත් බැරි වුණා atom එක තමයි smallest particle එක කියන concept එකේ ඉඳගෙන. හරි. දැන් මොකක් හරි theory එකකින් පැහැදිලි කරගන්න බැරි වෙනකොට දේවල් ඒකෙන් ඒ theory එක ගැන trust එක build up වෙනවද? trust එක නැති වෙනවද? What happens when you can't explain your observations using your theories? You lose the trust regarding that theory. Am I correct, Lamai? Right? Since they could not be able to explain how these processes have been happening, the trust about golf ball model, where atom is the smallest particle of the element, was broken. Right? So it was broken. Then a person called Stoney, you have to memorize these names. A person called Stoney came up with the statement where these, what do you call, atom is not the smallest particle of the world, right? Atom has a subatomic particle which is said to be electron. That electron causes the background of these phenomena. That's what Stoney said. Stoney came up with the concept called electron. Stoney kiwa atom එක නෙමෙයි මේ ලෝකේ තියෙන smallest particle එක. atom එක ඇතුලේ තියෙනවා electron එක කියලා particle එකක්. ඔන්න ඔය electron එක කියන particle එකේ intervention එකෙන් තමයි මේ processes occur වෙන්නේ. එහෙම particle එකක් නෑ atom එක තමයි චූටිම කියලා අපි හිතන හින්දා තමයි we are not able to explain these stuff කියලා. So the person Stoney came up with the concept of what? Electron. Right? That's how the concept of electron came. He didn't discover the electron. Who discover करे ने? Thomson came up with set of experiments and came up with the confirmation of identifying electron that we have to study later. But up until the concept, Stoney came up with the concept of electron due to the failure of explanation of these three phenomena. Right? Right. I'll be going forward with the note. Look at this, Buddha. Stoney proclaimed that matter which consists of solid, liquid and gaseous states to display phenomena such as static electricity, electrochemical cells and electrolysis, it should have an electrical nature. Right? Matter must be having an electrical nature to showcase these static electricity, electrochemical cell operation and electrolysis kind of stuff. Also he stated that matter contains its electrical nature since its smallest building unit named atom contains a particle with electrical nature. Later he named that particle as the electron. Right? So who came up with the concept of electron? Stoney. Because of what? How he came up with the concept? Because of the failure to explain these main three phenomena, static electricity, electrochemical cells and electrolysis only, he came up with the concept electron. Right? Right. යටින් ලියන්න පැරා එකක් මෙහෙම. To assess, to evaluate කියත් කමන්නේ. To evaluate Stoney's statement, you may write down lamai. To evaluate Stoney's statement, to evaluate Stoney's statement, to evaluate Stoney's statement, Crookes, these are names, huh? Crookes, to evaluate Stoney's statement, Crookes, comma, heat of and fluke to evaluate Stoney's statement. Crookes, heat of and fluke conducted an experiment conducted an experiment based on electrical conductivity of a gas under high voltage and low pressure conditions. Electrical conductivity of a gas under high voltage and low pressure conditions. Under high voltage and low pressure conditions. High voltage and low pressure conditions, which is said to be you may write within double commas, electrical discharge property, which is said to be electrical discharge property, right? Huda, who conducted an experiment to validate Stoney's statement whether electron is available or not in an atom? Who conducted this experiment? If someone asks for a single name, what name you have to write? Crookes. He led the way, right? He was leading it. Crookes. If someone want you to come up with 3 names, assistants as well, what are the names? Crookes, Hitov and Fluke. Using which property they conducted this experiment? Using electrical discharge property. What is electrical discharge property? Which also contains in the paragraph. What is electrical discharge property? Conductance of electricity within a gas under which conditions? Under high voltage and low pressure conditions. Anne condition again gas එකකින් current එක conduct කරන එක තමයි කියන්නේ. හරි. I'll be moving further. 3 of them created an anode and a cathode using a glass tube and connected it to a vacuum pump and a high voltage supply. Right. Puda, this is what Crookes and company did. Right. Crookes we team එකයි කරේ මෙන්න මේ වගේ වැඩක්. Gas tube එක, glass tube එකක, හරි? Glass tube එකක anode එකකුයි cathode එකකුයි connect කරගත්තා. හරි? මම මේක external supply එකේ රිනට set වෙනවා කියලා කියන්න negative pole එකට. So this becomes the cathode. මේක external supply එකේ positive pole එකට set වෙනවා කියන්නම්. Hence this become the anode. Right? So මේ anode එකයි cathode එකයි connect කරා high voltage supply එකකට. හරි? මේ දෙක connect කරා high voltage supply එකකට. High voltage supply. This was connected to a high voltage supply. හරිද? connect කරලා vacuum pump එකකින් මේ glass tube එක ඇතුලේ pressure එක අඩු කරා. right? vacuum pump එකක් කියලා කියන්නේ අර අපේ normal air pump එකක වැඩේ අනිත් පැත්තට කරන කෙනෙක්. it acts reversibly like a conventional air pump. අපි conventional air pump එකක් connect කරොත් වෙන්නේ atmospheric gas එක මේ gas tube එක ඇතුළට ගිහිල්ලා මේකේ pressure එක වැඩි වෙන එකනේ. when we apply vacuum pump on this, it absorbs whatever the available gas molecules and releases to the atmosphere. So the number of gas molecules will be decreasing. ඒ කියන්නේ pressure එක මොකද වෙන්නේ මේ glass tube එක ඇතුලේ? අඩු වෙනවා. Pressure decreases gradually when we pump the vacuum pump. So vacuum pump එක connect කරලා මේ glass tube එකේ pressure එක අඩු කරා. හරි? ඒ කියන්නේ අරගොල්ලෝ කරපු වැඩේ. Crooks and team. Right. When they apply about 10,000 volt voltage, right? 10,000 volt විතර voltage එකක් දීලා. These figures you don't need to memorize. ඇතුලේ pressure එක pascal එකකට විතර අඩු කරනකොට, right, when they reduce the pressure to about 1 pascal, like what happened was they could see a green color illumination behind the anode. මෙන්න මේ anode එක පිටිපස්සේ, if you have a green color pen or pencil, you better use it. If not, you just use your whatever the blue or red pen and make it. A green color illumination could be observed. A green illumination could be observed under this condition, right? When they search why this illumination could be seen, they could see a colorless beam of rays which starts from cathode. Cathode එකෙන් පටන් ගන්න color එකක් නැති beams මේ කිරණ ටිකක් rays ටිකක් ගිහිල්ලා මේ anode එක පිටිපස්සේ glass wall එකේ වදින හින්දා තමයි මේ green color illumination එක එන්නේ කියලා they could see, right? Cathode එකෙන් පටන් ගත්ත rays කියන idea එක ඇතුව, right? I mean to imply the idea that these rays have been origin from the cathode. These rays were known to be which rays then? Cathode rays. Later, Thomson and his team worked with these cathode rays to come up with the discovery of electron. That's a different story that we'll see later. But Crookes and company, they drove the research until they find out these cathode rays. මේ cathode rays අඳුර ගන්න තැනට එනකන් Crookes සහ යාගේ team එක මේ cathode ray මේ experiment එක අරගෙන ගියා. හරි. ඕක තමයි ඔය කියන්නේ පුතා. බලන්න මේ 3 of them created an anode and a cathode using a glass tube and connected it to a vacuum pump and a high voltage. When the voltage is increased to 10,000 volts and the pressure is decreased to 10 pascal, a darker region is created around the cathode. May cathode එක ගාව darker region එකක් ආව. That we don't need to memorize that. This region is known Crookes dark region. This was known to be Crookes dark region. When the pressure is further reduced and reached less than 1 pascal, a green color glow is observed in the opposite side of the cathodic of the tube. Cathodic end of the tube. In the opposite side of the cathodic end. Cathodic end එක කියන්නේ මේක නේද? ඒකට opposite end එකේ green color illumination could be seen. Right? A green color glow is observed in the opposite end of the cathodic end of the tube. Right. Under that, you can draw this particular diagram there, Buddha. Draw this. Mark it as cathode and anode. Vacuum pump must be shown. High voltage supply using this dotted line can be represented as well. Right. You may label the green illumination or else green glow and the beam of cathode rays as well. Cathode rays ටිකකුත් අපි පෙන්නමු. The green illumination and the cathode rays must be shown. The green illumination and cathode rays must be shown. these letters are not clear, I can dictate later. Diagram में कहना करना glass tube, anode, cathode, vacuum pump, high voltage supply, cathode rays. Especially behind the anode, you must show the green illumination. Green color pen එකක් තියෙනවා නම් ඒකෙන්ම දාන්න නැත්නම් නිකන් ලීවට කවන්නේ. Green illumination. Green illumination. අපි දවසේ උගන්වන ඒවා දවසේ පාඩම් කරලාමයි යවන්නේ හරි. So we have to manage day by day. එක class day එකකින් ඊළඟ class day එකට if we can properly manage, we can quickly progress in the subject. I need you guys to convey the message for your friends as much as you can these days, huh? Because this is the first time I'm physically doing an English medium class. So විශේෂයෙන් ඔය කුරුණෑගල physically එන set එකට මම කියන්නේ convey the message among others as well as much as you can. Right. I'll be moving further. Later, they identified that the reason for the occurrence of green color glow in the opposite side to the anodic end, not the anodic end, it has to be cathodic end. Correct it. In the opposite side to the cathodic end, is collision of invisible rays on the glass tube that are emitted from the cathode. මේ cathode එකෙන් emit වුණු invisible rays ටිකක්, colorless rays ටිකක් ගිහිල්ලා anode එකට පිටිපස්සේ glass wall එකේ collide වෙන එක තමයි මේ glow එකට හේතුව කියලා they reasoned it out. As those rays are emitted from the cathode, they were named as, highlight the word, cathode rays by them. So the Crookes and team came up with the concept called cathode rays. During the second step, Thomson and other scientists conducted experiments to determine the characteristics of cathode rays. Right? During the second stage of this electron discovering process, Thomson and his mates conducted a series of experiments to identify the properties of these cathode rays. මේ properties cathode rays වල properties හොයන්න Thomson and company they conducted a series of experiments. Right. So there's a QR code, right? Later when you are studying at home, you can do these things, not here. Scan the QR code below and refer to the video to study about cathode ray tests. So I have animations and several videos where you can get the things absorbed more effectively by scanning these QR codes. You can reach, right? පාඩම් කරන වෙලාවේ scan කරලා බලන්න. Right. Characteristics of cathode rays. First one, travel in straight lines. Cathode rays කියන්නේ travel කරන්නේ මොන lines වලද? Straight lines වල. Right. පුතා, see how it was understood, right? මේක කොහොමද තේරුම් ගත්තේ කියලා බලන්න Thomson ඇතුළු set එක. Right. You know what Thomson did? මම දැන් මේ vacuum pumps, high voltage supplies ඒවා අඳින්නේ නැහැ. Right? So Thomson used a cross-like thick metal object, I can say an opaque object, as his anode. Right? Make a cathode එක මේක anode එක. ඒතර Thomson එයාගේ anode එක විදිහට use කරා a cross-like opaque object. What do you mean by opaque object? You know what the meaning of transparency, opaqueness, and you know, right? What is an opaque object? Maybe something built with thick metal where rays are not passing through. Am I correct? Light waves hari monawa hari pass through when නැති type එකේ වට අපි කියන මොන objects කියලාද? Opaque object. A thick metal cross was used as anode. Right? Listen to me very carefully, right? When Thomson positioned a thick metal object, an opaque object, a cross-like opaque object as in the form of anode, right? Thomson could see a dark image with sharp edges. A dark image with sharp edges as the image of this object. ඒ කියන්නේ Thomson පෙවුන පුතා මේ blur වෙච්ච edges නෙමෙයි අර මේකේ තියෙන ඉරිකැලි විදිහටම තියෙන sharp edges තියෙන dark black color image එකක් cathode rays වලින් මේ object එකෙන් පිටිපස්සේ හැදෙනවා කියලා. Behind the object, Thomson and team could observe an image, a dark image with sharp edges. Sharp edges තියෙන image එකක් දකින්න හම්බුණා. Using this observation, right? Using this observation, Thomson said these cathode rays are propagating in straight lines. Making Thomson kiwa මේ cathode rays කියන්නේ යන්නේ straight lines වල. කියන්නේ මේවා මෙහෙම waves වගේ නෙමෙයි යන්නේ. මේවා යන්නේ straight lines වල කියලා මෙයා කිව්වා. I'll give you a furthermore explanation. Right? Answer me, yeah? Talk louder, හරිද? Otherwise I can't get the feeling whether you absorbed or not. That's why. Right? Let's say I'm hanging this book in the ceiling. මම මේ ceiling එකේ මේ book එක එල්ලනවා කියලා හිතන්නකෝ. Right? If cathode rays are coming from your end to my end, right? In wave kind of forms. නිකන් මෙහෙම ගැරන්ඩියා ගියා වගේ wave kind of forms වලින් එනවා කියලා හිතන්නකෝ. The image of this edge, if these rays are coming in this way, right? The image of this edge, will it be sharp or blunt? මොකද කියන්න තියෙන්නේ මෙහෙම එනවනම් මේ edge එක දිගේ එන cathode rays ටික. Blunt. මෙහෙම නේද ඒකේ edge එක එන්නේ. මේ edges වලත් එහෙමමනේ. Right. Let's say cathode rays from your end are coming in straight lines වල එනවා කියලා හිතන්නකෝ පුතා. ඒතර මේ edge එක දිගේ එන ඔක්කොම cathode rays ටික මෙහෙම straight lines වල නම් එන්නේ. මේකේ image එක මේ board එකේ වැටෙනකොට කොයි විදිහේ edge එකක් වාට හම්බෙයිද? Is it a blind edge or will it be a sharp edge? Sharp kind of an edge. Am I correct? Right. So මේ තියෙන හැම edge එකක්ම sharp edges විදිහට ඇවිල්ලා that concluded the fact that අර මම කියපු විදිහටම අපි හිතුවොත් if you think in that way, this concludes the fact that cathode rays are moving, or the propagation of cathode rays are in which lines then? Straight lines, arrow like straight lines. තේරෙනවද මම කියපු එක? So that's how Thomson came up with the concept. But I'll be using techniques, I mean, what do I call the technology as much as I can to explain whatever the things. Right? So it's like this. Right? You can see now how sharp edges can be seen there, right? So cross-like object was used. Very sharp edges can be seen. You can see here, these edges are very, very sharp, right? Sharp edges can be seen there. So that's how Thomson came up with the fact that these are moving in straight lines. හරි අපි explanation එක ලියමු. ඉස්සෙල්ලාම diagram එක will name it up. Minus electrode එක anode එක කියලා දාන්න. The positive electrode can be said as anode, minus one is cathode. Right. This is cross-like opaque object. Cross-like opaque object, and this dark image with sharp edges. These characteristics has to be written. Dark image with sharp edges. Dark image with sharp edges. Cross-like opaque object, dark image with sharp edges. Like opaque object, dark image with sharp edges. Right. You may write down the explanation. Lianna. when a cross-like opaque object is positioned, යටින් තියෙන ඉඩේ පැර එකක් විදිහට චූටියට ලියන්න. You can't write with larger letters පොඩි අකුරෙන් ලියන්න ඉඩ manage කරා. When a cross-like opaque object is positioned in the way of cathode ray, in the way of cathode rays, in the way of cathode rays, a dark image with sharp edges could be observed. A dark image with sharp edges could be observed. A dark image with sharp edges could be observed. A dark image with sharp edges could be observed. Right. Later, secondly, Thomson identified the fact that these cathode rays consist of particles. In other way, this can be written as cathode rays has a momentum. මොකක්ද තියෙනවා කියලාද අඳුරගෙන තියෙන්නේ? Momentum එක. කියන්නේ cathode rays කියලා මේ propagate වෙන්නේ waves නෙමෙයි. small particles තමයි cathode rays කියලා straight line එක මේ propagate වෙන්නේ කියලා identify කරගෙන තියෙනවා. Right. To identify this, Thomson and his team, positioned a rotatable paddle wheel. මේකට අපි කියනවා paddle wheel එකක් කියලා. හරි? rotate වෙන්න පුළුවන් paddle wheel එකක්. මෙහෙම කැරකෙන්න පුළුවන් රෝදයක්. rotatable paddle wheel was positioned in between the cathode and anode. Right? Anode එකයි cathode එකයි මැද්දේ rotatable paddle wheel එකක් මේගොල්ලෝ position කරලා තියෙනවා. So this is what Thomson and mates did to explain the thing that these cathode rays consist of particles. Right? You may name your diagram. This is cathode and anode. This you can explain to be rotatable paddle wheel. Rotatable paddle wheel. Rotatable paddle wheel. Rotatable paddle wheel. Give me 1 minute, I'll come up with my calculator and all, right? Give me 1 minute. Read the note about. We have to reduce the AC. Okay, AC got to run again. Right, give me 2 minutes. You read up until then. Or then I can take a key one. Right, you may write down, right? Sorry for taking your time for 2 minutes. Right, you may write down, adding, when a rotatable paddle wheel is positioned, when a rotatable paddle wheel is positioned, when a rotatable paddle wheel is positioned, in the way of cathode rays, the way of cathode rays, it rotated towards the direction of cathode ray movement. It rotated towards the direction of cathode ray movement. It rotated towards the direction of it rotated towards the direction of cathode ray movement. Cathode ray එක flow වෙච්ච direction එකට move වෙනවා. Direction of cathode ray movement. Right. Now Thomson and his team knows two characteristics of these cathode rays. Characteristics දෙකක් දන්නවා. මොනවද දන්නේ? These are moving in which lines? Talk, come on. These are moving in straight lines. This consists of waves or particles. ඒ කියන්නේ අපි light waves වගේ waves නෙමෙයි මේ යන්නේ. මේවා මොනවා කියලාද දන්නේ? Particles කියලා. Right. I'm asking a question from you. මම ඔයාලගෙන් question එකක් අහනවා. කොහොමද මේ paddle wheel එක rotate වෙනවා කියන එකෙන් prove වෙන්නේ cathode rays consist of particles කියලා? How does the rotation of these paddle wheel towards the direction of cathode rays prove you the fact that cathode rays are consist of particles, not waves? How it get proven? How it proves? Right. Shall I tell you something? Let's say I'm hanging this tube in the ceiling. Right. मैं ceiling के मैं hang करना के लिए इतना Right. I'm giving you a high pressure water gun. अरे वाहन वाला याटा service करा दी उसका high pressure water gun से I'm giving you a high pressure water gun and I'm asking you to focus it on the tube. මොකද වෙන්නේ high pressure water jet එකක් ඇවිල්ලා මේ tube එකේ වැදුනොත්. වදිනකොටම මේක this moves backward. Am I correct? මේ එල්ලලා තියෙන එක මේ පිටිපස්සට තල්ලු වෙනවනේ මේ වදිනකොට. With the noise it goes back, right? Right. Keep it away. I'm giving you a torch. What happens when you focus the torch on this surface? Torch එකකින් light beam එකක් ඇවිල්ලා වදිනකොට this get illuminated. Yes, I do admit the fact that this get illuminated. But with the light beam, is it moving backwards? ගෙදර curtain එකට torch එකක් ගහනකොට it goes back. When you apply your torch on a door, it goes back. Is it happening like that? Why such a difference? When we focusing a torch, a light beam on this, only light waves comes in and collide. But when we position high pressure water jet on this surface, what happens? Small water particles come and collide here, where they impose a force on this surface, where this goes backward. Am I correct? එනම් particles වලට තමයි force එකක් generate කරලා movement එකක් කරන්න පුළුවන්, not for the waves. Cathode rays කියන්නේ waves නම් ඒවා ඇවිල්ලා වදිනකොට paddle wheel එකේ only an illumination could be seen. But since these cathode rays consist of particles only, the rotation of paddle wheel towards the cathode ray direction can be seen. Am I correct, Lamai? So this conclude the fact that these cathode rays are consist of what? මේවා මොනවකින් හැදිලා තියෙනවා කියලාද මේකෙන් conclude වෙන්නේ? Particles only. Right. Now they know these are moving straight lines and these consist of particles. Right. Then Thomson wanted, once they realized that these consist of particles, මේවා particles වලින් හැදිලා කියලා දැක්කට පස්සේ Then Thomson wanted to see whether these particles are charged or neutral. Right? Thomson wanted to see whether these particles are charged or neutral. Right? Thomson did something like this, Buddha. Look at this. Thomson positioned, right, let's say the setup is like this, right? This is somewhat different setup. Anyway, I'll be drawing simplify කරලා අඳින්නම්, right? Cathode එක මේ direction එකෙන් මම අඳින්නම්, right? Cathode. Anode එක මම මේ පැත්තෙන් අඳින්නම්. This is my anode, right? Anode. එතකොට දැන් cathode rays මෙහෙම යනවනේ. cathode rays මේ වගේ trajectory එකකනේ යන්නේ මෙතනින් ගිහිල්ලා. මේ වගේ line එකනේ cathode rays යන්නේ. cathode rays යන line එකේ මම තියනවා මේ පැත්තෙන් magnet එකක south pole එකක්. මේ පැත්තෙන් තියනවා මම magnet එකක north pole එකක්. Right? Okay, ඔය ns මාරු කරගන්න. You have to swap these S and N letters in your diagram. S තියෙන තැන N කියලා දාගන්න, N තියෙන තැන S කියලා දාගන්න. Right. It's like this. Now, so physics comes into play. Physics only gonna, this is not chemistry, but anyway, I'll be telling you what happens. Right. Thomson positioned a perpendicular magnetic field in the pathway of cathode ray propagation. Cathode rays යන pathway එකේ ඒ direction එකට perpendicular direction එකට. හරි, perpendicular කියන්නේ මෙහෙමනේ 90 degrees නේ. එයා magnetic field එකක් position කරා. You know magnet has two poles, south pole and north pole, where magnetic field is believed to be towards from north pole to south pole. Am I correct? එහෙම නේද magnetic field එක තියෙනවා කියලා හිතන්න. magnetic field එක perpendicular cathode ray direction එකට. He positioned a perpendicular magnetic field to cathode ray direction. Right. What happened was these moving cathode rays, right? What happened was these moving cathode rays were deviating from its original direction. කියන්නේ මේවා straight line එකේ flow වුණා නම් මෙතනනේ අර green color illumination එක එන්න ඕනේ. එහෙම එන්නේ නැතුව මේක deviate වුණා original direction එකේ. This green color illumination was deviated from its original direction. Deviate වුණා. එහෙම වෙන්නේ, right? The reason behind that was this magnetic field could impose a force when these cathode ray particles going through it. Right? There's a rule in physics which is named to be Fleming's left hand rule. Have you heard of Fleming's left hand rule? අර මේ අතේ ඇඟිලි තුනක් තියාගෙන අපි කියන්නේ, you don't need to come up with that. There's a rule in physics which is said to be Fleming's left hand rule, where only charged particles deviates from their original way when they're passing through a magnetic field. That's a rule in physics. When we apply Fleming's left hand rule to this and we think reversibly, right, we can conclude the fact that these cathode ray particles are consist of what then? A charge. Because Fleming says only the charged particles deviates from their original way when they're passing through a magnetic field. So these cathode rays particles have deviated from their original way when they are passing through this magnetic field. So reversibly it says these cathode ray particles are consist of what then? A charge. Now charge particles කියලා එතනින් conclude වුණා. තේරුණාද මම කියපු එක? Right. අපි අපේ diagram එක update කරමු. We'll update our diagram and write down. Right. You take your diagram, will you? Right. So this is cathode, this is anode. You may label lah. You may label. Right. So this can be said as perpendicular magnetic field. Right. This is perpendicular magnetic field. This is perpendicular magnetic field. This can be said as deviation of cathode rays. Deviation of cathode rays. deviation of cathode rays. Deviation of cathode rays. Right. Leander, adding, you may write down under the diagram. Deviation of cathode ray beam. Deviation of cathode ray beam. Deviation of cathode ray beam according to Fleming's left-hand rule. According to Fleming's left-hand rule, according to Fleming's left-hand rule, deviation of cathode ray beam, according to Fleming's left-hand rule, according to Fleming's left-hand rule, concluded the fact that these cathode ray particles are charged. Concluded the fact that these cathode ray particles are charged. Concluded the fact that these cathode ray particles are charged. These cathode ray particles are charged. Concluded the fact that these cathode ray particles are charged. Right. Lamai, once they realize that these cathode rays are consist of charged particles, not the neutral particles, then they wanted to see whether these are positively charged or negatively. We have only two types of charge, positive charges and negative charges. They wanted to check whether this is positively charged or negatively charged. You know, Thomson and his mates, right? They positioned, Thomson and company, they positioned, I'm going with a very simple diagram, right? They positioned, which is plus, which is minus, right? Like this. You know, this they position two oppositely charged metal plates there. It's like this. Here, they positioned a positively charged metal plate here and negatively charged metal plate there. Right? Right. What they could see is, they could see deviation of these cathode rays. Deviation of these cathode rays towards positively charged plate. So, කෙලින්ම ගියා නම් glow එක green color glow එක එන්න ඕනේ මෙතන. එතන නැතුව positively charged plate එක පැත්තට cathode rays deviate වෙනවා. They could see. And we know oppositely charged particles are attracting to each other නේ. So, plus plate එකට attract වෙන්න නම් මේ cathode ray particles වල මොන charge එකක් තියෙන්න ඕනේද? These must be negatively charged. Then they concluded the fact that these are negatively charged particles. Right? Abi diagram එක update karamu. We may upgrade our diagram. Right? So the negative electrode is cathode. Abi negative electrode එක cathode කියලා ලියමු. Positive electrode එක අපි anode කියලා ලියමු. Negative electrode එක cathode, positive electrode එක anode. Negative electrode එක cathode, positive electrode එක anode. හරි. අපි මේක label කරමු deviation of cathode rays කියලා දාමු. Deviation of cathode rays. Right? Deviation of cathode rays. Right. You may write down underneath deviation of cathode rays. Deviation of cathode rays radiation of cathode rays towards positively charged plate, towards positively charged plate of an electric field confirmed the fact that cathode rays consist of negatively charged particles. 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 Audio again sounds the no? We are getting the sounds and all, no? Right. Negatively charged particles. Right. ඔය ටික තමයි ළමයින් Thomson හොයාගත්ත characteristics ටික. What are the main characteristics that Thomson observed? Cathode rays are flowing in which lines? Straight lines. They consist of particles. They consist of charged particles. They consist of negatively charged particles. Some other specific properties of cathode rays are can exert a pressure inside the cathode tube. Cathode tube එකේ pressure එකක් exert කරන්න පුළුවන්. Perpendicular emission with respect to the cathodic surface. They emit perpendicularly with respect to the cathodic surface. Heat generation capability once hit with a metal surface. Ability to travel through thin materials. Gas ionization capability, etc. Right. Puda, except to these main observations observed by Thomson and his team, scientists could see further more properties and or characteristics of these cathode rays, but not Thomson. Other scientists later on, they realized there are certain other characteristics as well. Those are, cathode rays could increase the temperature when struck in a metal surface. When struck on a metal surface එක දුන්නාම temperature එක වැඩි කරන්න පුළුවන්. Cathode rays can ionize gases. ඒ කියන්නේ hydrogen gas එක fill කරපු මේ bulb එකක් through, when we allow cathode rays to pass through a hydrogen bulb, that hydrogen molecules can be converted into H+ ions. Gas molecules ions වලට convert කරන්න පුළුවන්. That's called ionization capacity. They can go through a thin material. Thin paper එකක් වගේ through යන්න පුළුවන්. They can go through a thin material. Those are several properties. ඒ වගේ properties දෙක තුනක් පස්සේ කාලෙක හොයාගෙන තියෙනවා. Right. Later, Thomson further discovered about cathode rays and calculated charge upon mass ratio using different gases inside the cathode ray tube and using different metals as cathode. Pata, third stage ke Thomson changed the cathodic material. Sometimes he used magnesium plate as a cathode. Sometimes he used zinc plate as a cathode. Maybe a manganese plate as a cathode. He changed the cathode material. Plus, he changed the gas inside the cathode tube. Cathode ray tube එකේ තියෙන gas එකයි cathode material එකයි Thomson වෙනස් කර එක එක situation එකේ හම්බෙන මේ cathode ray particles වල charge upon mass ratio, which is represented as E upon M ratio. E upon M ratio එක calculate කරා. Right. E upon M ratio calculate කරා. Then he observed that the E upon M value remains constant even irrespective of the gas filled in the cathode ray tube and the material of the cathode. What he could see was, he could see something strange. What? The E upon M ratio, the charge and mass ratio of the cathode ray particle wasn't changing irrespective of the cathodic material and the gas filled in the tube. gas එක වෙනස් කරා cathodic material එක වෙනස් කරා කියලා E upon M ratio එක වෙනස් වුනේ නැහැ. හරි? Having seen that, Thomson finalized කරගත්තා, right, okay, so this cathode ray particle is a basic particle which does not change with the material or the gas. Material එකයි gas එකයි මොකක්වත් මත වෙනස් වෙන්නේ නැති basic particle එකක් කියලා finalize කළා. This is none other than the electron, where Stoney stated, having seen the static electricity, electrolysis and electrochemical cells කියලා මෙයා electron එක විදිහට මේ cathode ray particle එක discover කරගත්තා. හරි? එතකොට ඔහොම කතාවක් තමයි එක කියන්නේ මේ ray tube and the material of cathode ray. අර තියෙන space එක චුට්ටක් තියන් අපි යට තියෙන පැරා එකක් කියමු. Later it was proved that cathode ray particle is the electron, which is a basic particle common to all the matter, which was named by Stoney. Right? Stoney කියන කෙනා කියපු cathode මේ electron එක තමයි මේ cathode ray particle එක කියලා Thomson finalize කරගත්තා. Right? ළමයි එතන උඩ space එකක් තිබ්බනේ අපි අතහැරපු space එකක්. හරි. අපි ඒකේ මේ electron එකේ නැත්නම් cathode ray particle එකේ E upon M ratio එක ලියමු. Right? We must memorize this figure. අර උඩ තියෙන ඉඩය left hand column එකේ උඩ තියෙන ඉඩේ ලියන්න E upon M of cathode ray equals 1.759 into 10 to the power of 11 coulombs per kilogram. E upon M equals 1.759 into 10 to the power of 11 coulombs per kilogram. You may write down and highlight it. You have to memorize these figures. This is the E upon M, the charge upon mass ratio value of electron. E upon M. This is the charge upon mass ratio value of electron. Right. We may continue the reading of this paragraph. Later it was proved that the cathode ray particle is the electron, which is a basic particle common to all matter, which was named by Stoney. Right. Charge of an electron is determined by Millikan's oil drop experiment. Right. You may highlight few words. Millikan and oil drop experiment. Okay. Once E upon M ratio was calculated by Thomson by this means, later a person called Millikan came up with a special kind of an experiment said to be the oil drop experiment, and he determined the charge of an electron. Millikan කියන කෙනා oil drop experiment එකෙන් later after that electron එකේ charge එක discover කරලා තියෙනවා. Oil drop experiment we don't need in our syllabus, and you need to memorize this figure anyway. The charge of electron was found to be 1.602 into 10 to the power of minus 19 coulombs. Coulomb means the SI unit of expressing charge, which is capital C. Right? You may write down and box this up. Puda. E equals the charge of an electron equals yati. QR code එකට උඩ තියෙන space එකේ charge of an electron E equals 1.602 into 10 to the power of minus 19 coulombs. 1.602 into 10 to the power of minus 19 coulombs. 1.602 into 10 to the power of minus 19 coulombs. You are supposed to come up with something. QR code you just watch it later, right? Calculating the mass of electron, calculate, I would say, you would say calculate, right? Anyway, keep it. Calculating the mass of an electron using E and E upon M value, right? We are supposed to calculate the mass of an electron, M, using this E upon M ratio and E figure, right? It's like this, Pudha. Let's say we want to calculate the mass of an electron m. M equals what? Now grade 8, 9 maths comes into play. How we can determine m using these E upon m and E figures? E equals what? M equals what? M equals, see whether I am correct, E divided by E upon m. Am I correct? Yes or no? Yes, no. When we divide E by E upon m, E to E will be cancelling off. The denominator here would go up as the numerator and we are getting the value m. Am I correct? Right. So what is E? It came with Millikan's oil drop experiment. What is E? 1.602 into 10 to the power of minus 19 coulombs. What is m? E upon m. What is E upon m actually? 1.759 into 10 to the power of 11 coulombs per kilogram. Am I correct? Right. You have to come up with these simplifications. May scientific notation simplifications O-level maths වල තිබ්බා. හවුද? O-level maths කරලා අවුරුදු දෙකක් නැනේ තාම. නේ, it's about 2 to 3 weeks now නේ. Right? So you have to come up with these answers. This up to you. මේක ගෙදරින් කරලා බලන්න. M equals, if I have not mistaken, the answer is about 9.107 into 10 to the power of minus 31 like kilograms. So you have to memorize this figure as well. Right? M equals 9.107 into 10 to the power of minus 31 kilograms. Right? So substitute karanna, figure වලට එන්න, memorize karanna, ලියා ගන්න. Right. ළමයි, you will be given 5 minutes. Right? විනාඩි 5ක් දෙනවා මං. It's not an interval. Interval එක නෙමෙයි හොඳේ. You just go through the everything we studied up until now. We covered 2 subtopics by now. Introduction, subtopic A, cathode rays and electron, subtopic B. හරි. ඔතෙන් දෙනකම් full note එක එකසරක් කියවන්න. You can ask anything directly from me. Ask from NJK type කරන්න, physically ඉන්න අය online chit එවන්න. I don't need to repeat it again and again. It's up to you. Right. අපි BD කියන subtopics දෙකත් අද cover කරමු. We can do that. මේ අපේ subtopics වල ටියුට් එකේ පොඩි වැරද්දක් තියෙනවා. You have to adjust it. Come to the first page, will you? A, introduction. First chapter ke first subtopic ke A, introduction. B, cathode rays and electrons. It has to be B. B, cathode rays and electrons. A, introduction. B, cathode rays and electrons. Then C, page number 3 I am referring. C, positive rays and protons. C. Page number 5. D, nuclear disparity and neutron. D, nuclear disparity and neutron. E, Thomson's plum pudding model. E, Thomson's plum pudding model. F, Rutherford's nuclear model. Rutherford's nuclear model. Right. Positive rays and protons, right? You read, will you read until the first half of page 3? You can ask anything from me, Lamaya. Ask anything. Lamaya, I want all of the live people, you to get involved actively in that Astromangy group, right? If you are not responding me properly quickly, then so this is not going to be very interactive then. Everyone must be responding there in the group from next Friday onwards. And the physical students, right? Again, otherwise this becomes death. In a marriage class, so this has to be very interactive kind of a session. Because we are working really hard. We have a very strong materials and we have a very strong program also. So you have to be very, very, I would say, interactive, right? You have to respond me very actively. So you all do not very lazy. Right. Shall we sum up things a little bit? Right? Hi, it's like this, Pudha. So we studied about the history of atomic structure. I mean, that's the main part, the main chapter we are working, under which we studied about the introduction part and the electron discovery part. Right? Right. It's like this. The chemistry is the subject. Now, relax. Chemistry is the subject which studies about properties and behaviors of matter. Matter means something which occupies a volume and which has a mass, right? Matter has 3 states: solid state, liquid state, torque, solid state, liquid state and gas state, gaseous state, right? Scientists believed the fact that all this matter is made out of elements, right? The definition of elements was first given by Empedocles far ago, about 400 to 500 years ago. Like, he stated the fact that there are 4 elements available in the world, which is soil, fire, air and water. Later on, when Hindus were ruling the world, they came up with the concept of 5 elements, where 4 elements was same as Empedocles introduced. The 5th one was space. So they believed every matter is made up with 5 elements: space, soil, fire, water and air, right? When Greek domination was there, when Greek people, they came up with a lot of mathematical concepts and all, a person called Democritus revolutionarily changed the concept of elements. He stated the fact that everything, every matter is made out of indivisible, invisible kind of very small particle which is believed to be an atom. Right? When the European countries, Aristotelian, what do you call the culture and everything was there, the European shifting of domination was there after, I would say, the Industrial Revolution or whatever, I don't know. Right? Plato and Aristotle, they said, no, it's wrong. There's nothing called atom. Everything is made out of gas, air, fire, kind of those things. Right? Anyway, with the time movement and everything, when British were having colonies and they were dominating the ruling power of the world, a person called John Dalton, he reinvented or else re-popped up the concept called atom. Democritus' concept called atom was popped up, but in a more comprehensive way, more detailed way. Yes, Thomson said, what do you call the Dalton said, everything is made out of atoms. Atoms cannot be created or destroyed with chemical reactions. Various elements consist of various type of atoms. Atoms of all elements are not similar. These various kind of atoms are combined in simple whole number ratios to derive various compounds which made everything around us. That kind of model he introduced. That model, that law, that theory is said to be Dalton's atomic theory. The overall model he developed based on these atom and its concepts is believed to be the golf ball model. Golf ball model is expected to be the basis of modern chemistry. ඉතින් අර historical chemistry ඉවර වෙලා ගිහිල්ලා modern chemistry එකේ base එක විදිහට ඒක එනවා. Right. So people believed Dalton's atomic law and the golf ball model, and then they started to building up the subject called chemistry. And when they build up the subject chemistry, they could observe certain phenomena or observations which cannot be explained using the atom is to be the smallest particle of matter. What were those special kind of observations? What were those phenomena? Static electricity was one, electrochemical cell operation was another, and the electrolysis process was the third one. They couldn't explain the background of these electrolysis, electrochemical cells and static electricity, having said that the atom is the smallest particle of matter. Right. Since they stuck there, a person called Stoney stated something really, really interesting. He said, look guys, we are wrong. Atom is not the smallest particle ever. There's a small particle inside atom which is said to be electron, which creates all these static electricity, electrolysis and electrochemical cells, stuff like that. He came up with the subatomic particle, or he came up with the concept called electron, which are available within an atom. Right. Scientists, they didn't believe Stoney at once because they were sticking to golf ball model. Golf ball model was the basis of modern chemistry, as I said. So they didn't believe Stoney. However, a person called Crookes with his supporters, Heatoff and Fluker, wanted to evaluate whether this Stoney's statement is true or not. They conducted an experiment using propagation of electricity within a gas under high voltage and low pressure conditions, which is said to be electrical discharge property. And he positioned a glass tube with an anode and cathode, and he reduced the pressure inside this gas tube using a vacuum pump, where the high voltage about 10,000 volt was supplied among anode and cathode. Anode එකයි cathode එක අතර volt 10000ක විතර high voltage එකක් දීලා vacuum pump එකෙන් gas tube එකේ pressure එක අඩු කර අරයාගේ statement එකේ validity එක check කරන්න experiment එකක් electrical discharge property එක base කරගෙන Crookes and team එක කරා. When the pressure is decreased like 1 pascal වගේ වෙනකොට, they could see a green color gloss behind the anode. gloss එකක් ආවේ cathode එකෙන් පටන් ගත්ත rays જાතියක් ගිහිල්ලා වදින හින්දා කියලා they identified. Cathode එකෙන් origin වුණු rays කියන අදහස තු those are said to be which rays then? Cathode rays. Then how the cathode ray concept came? Crook observed cathode rays. He couldn't carry on the experiment further. උට එතනින් ඉස්සරහට යන්න බැරි වුණා. He failed then after. He didn't have any pathway to analyze cathode rays and go forward. But anyway, Thomson took the baton. Right? A relay එකේ ඊළඟ baton එක Thomson ගත්තා. Thomson conducted a series of experiments to understand these properties of these cathode rays. He observed 4 main properties of these cathode rays. What are the main properties of cathode rays? Flowing in straight lines, consist of particles, consist of charged particles, consist of negatively charged particles. Except to that, there are certain other properties, later identified properties, but main properties are these. During the third stage of the study, Thomson changed the cathodic material and gas filled inside the cathode ray tube and observed the charge upon mass ratio, which is denoted as E upon M ratio of these cathode rays. මේ cathode rays වල cathodic material එකයි ඇතුළට fill කරන gas එකයි වෙනස් කර E upon M ratio එක මෙයා calculate කරා. කවුද? Thomson. Something interesting was seen. එයා දැක්කා මේ materials වෙනස් කරාට ඇතුළට fill කරන gas එක වෙනස් කරාට E upon M ratio එක වෙනස් වෙන්නේ නැහැ. It wasn't changing. It wasn't changing at all. Hence, Thomson concluded the fact that this cathode ray particle is a basic building block, basic particle available in every element, which is none other than the electron, where Stoney stated. Stoney state karapu electron එක තමයි මේ cathode rays කියලා යන්නේ කියලා එයා conclude කළා. So, the concept of electron was given by Stoney. However, the discovery of electron was done by whom? Is it Stoney or Thomson? Thomson. Discovery of electron. The credit of discovery of electron is going to Thomson. Thomson was doing the discovery. Concept came with Stoney. Right. Later, a person called Millikan කියලා dial එකක් oil drop experiment එක කියලා experiment එකක උදව්වෙන් මේ electron එකේ charge එක හොයාගෙන තියෙනවා. It's 1.602 into 10 to the power of minus 19 coulombs. අපි ඒ figures දෙක base කරලා simple mathematical calculation එකකින් simple නෑ අපිට නම් but in maths it's simple, right? අපි derive කරා electron එකේ mass එක. It was what? 9.107 into 10 to the power of minus 31 නේ. මේ mass එක වුණා 9.107 9.107 into 10 to the power of minus 31 kilograms. හරි? So that's it. So ඔක තමයි electron එකේ story. හරි පොඩි වීඩියෝ ක්ලිප් එකක් තියෙනවා. ඔඩියෝ ඔක්කොම ටික ඕකේ නේ. පොඩි වීඩියෝ ක්ලිප් එකක් තියෙනවා electron එක ගැන. මම ඒක නිකන් play කරන්නම් to give you just an understanding, right? අපි මේ කතා කරපුවා තමයි ගොඩක් තියෙන්නේ.
Properties of cathode rays. Cathode rays travel in straight lines. In the cathode ray discharge tube, when metal object shown as cross is placed along the path of cathode rays, then it was observed that the shadow of the metal object is obtained on the glass wall opposite to that of cathode. From this observation, one may conclude that cathode rays travel in straight lines. Cathode rays are negatively charged. Let the anode of discharge tube is provided with holes and arranged with a photographic zinc sulfide screen. When cathode rays are made to pass through the perforated anode, then green light flashes or scintillations were noticed on zinc sulfide screen exactly in line with the holes on anode. This phenomena of light flashes on zinc sulfide screen is called fluorescence. The movement of invisible cathode rays towards positively charged anode clearly indicates that cathode rays are negatively charged particles. Cathode rays and electric field. Let electric field, shown as positive and negatively charged plates, is applied perpendicularly across the path of cathode rays in a cathode ray discharge tube. Then it was observed that cathode rays are deflected towards the positively charged plate. This attraction of cathode rays towards positively charged plate clearly indicates that cathode rays are negatively charged. Cathode rays and magnetic field. Cathode rays are deflected by magnetic field. A magnetic field via magnet is applied perpendicular to the plane of cathode rays, with the north pole pointing closer to the cathode ray discharge tube. Then it was observed that the cathode rays are deflected towards the north pole of the magnet, while when magnetic field with south pole pointing towards cathode rays is applied, then cathode rays were deflected away from it. This indicates the negative character of cathode rays. Cathode rays and particle nature. A paddle wheel, as shown, is placed along the path of cathode rays in cathode ray discharge tube. As the cathode rays pass through the paddle wheel begins to rotate. This indicates that the cathode rays have got particle nature with a specific mass. Now, cathode rays consisting of particles on collision with solid paddle wheel transfers its momentum as well as energy, and thereby makes the paddle wheel move with a particular velocity. This experiment confirms the particle nature of cathode rays. Finally, from all these cathode ray discharge tube experiments, one may conclude that cathode rays consist of negatively charged particles called as electrons.
Right, it's like this. So that's it. අපි දැන් යමු තව එක subtopic එකකට. හරි? Right. අපේ මාතෘකාව we are moving to the subtopic C under first chapter, which is positive rays and protons. We are going to study about the discovery of protons. කොහොමද atom එක ඇතුලේ protons කියලා subatomic particles જાතියක් තියෙනවා කියලා හොයාගත්තේ කියන එක. හරි. පුතා listen to me carefully. The concept proton came accidentally. Again, it was not a planned experiment, right? The person who's responsible was Goldstein. Goldstein කියලා scientist කෙනෙක් හිටියා. හරි? Goldstein කියලා scientist කෙනෙක් හිටියා. එයා මේ anode එක normally use කරලා he used a normal anode. හරි? Perforated cathode එකක් use කරා. Perforated cathode. Perforated cathode එකක් anode එකත් එක්ක use කරා. anode එක normal, cathode එක perforated cathode එකක්. හරි? හිල් තියෙන cathode එකක්. use කරලා එයා normal විදිහට මෙතන high voltage එකකුයි vacuum pump එකෙන් less pressure එකකුයි apply කරද්දී Goldstein දැක්කා he observed a red color beam of rays හරි මේ red color beam of rays which originated in between anode and perforated cathode was passing through the holes of these perforated cathode behind opposite to the cathode direction. Cathode එක පැත්තට නෙමෙයි අනිත් පැත්තට මේ perforations වලින් පිටිපස්සට යන red color beam එකක් එයා දැක්කා. To imply the name rays which passes through holes, he came up with the name canal rays. මේවට holes through pass වෙන rays කියන අදහස ඇතුව මේ Goldstein කියන scientist නමක් propose කරා මොන rays කියලාද? canal rays. මෙන්න මේ canal rays ගැන කරපු research එකකින් ඉස්සරහට ගිහිල්ලා තමයි atom එක ඇතුලේ මේ protons කියලා positively charged particles જાතියකුත් තියෙනවා කියලා පස්සේ කාලෙක හොයාගත්තේ. Right. We'll move with the note, right? We get the startup. After analyzing the cathode rays, scientists named Goldstein, highlight the word, conducted experiments to generate cathode rays using a perforated cathode in a glass tube. Here, cathode rays are also generated while another red color beam of rays traveling opposite to the direction of cathode rays through the holes of cathode were formed. Right. අපි මේ diagram එක ඇඳලා label කරමු පුතා. Positively charged electrode එක you label it as anode. Positively charged electrode එක label කරන්න anode කියලා. So this must be labeled as perforated cathode. Perforated cathode. Anode, and the second one should be perforated cathode. Right. You may use your red pen and draw a beam of rays which originates in between anode and perforated cathode and passes through the holes of cathode. Anode එකයි cathode එකයි මැද්දෙන් පටන් අරන් cathode එකේ holes through pass වෙන rays beam එකක් අදින්න. Label it as canal rays. Canal rays. These are red color in nature. Canal rays. Canal rays. Screen එක share කරනවා. Right, so these are canal rays. See, those are reddish in color. So normally the cathode rays in a gamang, red color ke beam එකව, those are said to be canal rays, right? Right, okay. Right, I'll be moving further. As these rays traveling through the holes of cathode, Goldstein named those rays as canal rays. You may highlight the word canal rays. Later, Thomson discovered that these rays are positively charged particles. These rays are consist of. You may put something and write it. Consist of. These rays are consist of. These rays are consist of positively charged particles. Consist of positively charged particles. And he named them as positive rays. During the second step, Thomson and other scientists determined the properties of positive rays. Right, Pudha. These canal rays, when Thomson and his mates examined the properties of these canal rays, they could see these canal rays consist of positively charged particles. Then they renamed these canal rays as which rays? Positive rays. Right. There's another synonym to this. Anode rays, since these are not starting from anode, but since these are starting from anodic direction, anode එක පැත්තෙන්නේ පටන් ගන්න. මේ canal rays වලට positive rays කියන word එක වගේම anode rays කියලාත් කියනවා. positive rays කියන word එක වගේම anode rays කියලාත් කියනවා. right. අපි ඔය diagram එකට යටින් මේ නැත්නම් sub topic එකට යටින් චුට්ටක් ලියමු positive rays කියලා නවත්තපු තැන within brackets positive rays equals anode rays. අපි මෙහෙම නිකන් brackets ඇතුලේ ලියමු. Positive rays equals anode rays. Positive rays equals anode rays. Positive rays equals anode rays. Right. Properties of positive rays. We don't need to draw diagrams, we'll move very quickly. Right. Thomson and his mates, they observed, right? They observed these positive rays are flowing in straight lines. මේවා straight lines වල යනවා කියලා Thomson හොයාගත්තා. කොහොමද හොයාගන්නේ නැත්තේ? What was the observation? මොකද ඔයාලට හිතෙන්නේ observation එක? ළමයි talk please. අර cathode rays වල experience එකෙන් මට කියන්න. They would have positioned a cross-like opaque object in the trajectory of positive rays. නේ? What kind of image could be seen? මොන වගේ image එකක් දකින්න ඇද්ද? A dark image with which edges? Sharp edges. Right. ලියන්න. Once a cross-like opaque object was positioned. Once a cross-like opaque object was positioned. Once a cross-like opaque object was positioned. A cross-like opaque object was positioned. Midway of canal ray beam. Midway, මැදෙන්. Midway of canal ray beam. Midway of canal ray beam. A dark image with sharp edges could be observed. A dark image with sharp edges could be observed. A dark image with sharp edges could be observed. A dark image with sharp edges could be observed. අපි sharp edges තියෙන dark image එකක් දැක්කා. A dark image with sharp edges could be observed. Right. Secondly, Thomson and his team observed, understood that these positive rays or the canal rays consist of particles. How come? කොහොමද මේවා particles වලින් consist වෙලා තියෙනවා කියලා හොයාගන්න නැත්තේ? They would have positioned a rotatable paddle wheel in the midway of these positive ray or canal ray flow, right? What kind of observation they could see? That paddle wheel must be rotating towards the direction of canal ray flow. Canal ray එකේ direction එකට මේක rotate වෙන්නේ නැති. හරි? ලියන්න. ඒ second එකේ once a rotatable paddle wheel was positioned. Once a rotatable paddle wheel was positioned. Once a rotatable paddle wheel was positioned. A rotatable paddle wheel was positioned in the midway of canal ray direction. 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 It was observed to be rotating towards same direction. It was observed to be rotating towards. It was observed to be rotating towards. It was observed to be rotating towards same direction. Same direction. Right. Tertiary, they understood these canal rays to be consist of charged particles. How come? A perpendicular which field was positioned? Is it an electric field or a magnetic field? a perpendicular magnetic field was positioned in the midway of this canal ray beam. So these canal rays deviated from its original direction according to the Fleming's left-hand rule. Right? Based on Fleming's left-hand rule, we could conclude the fact that these canal rays are consist of which kind of particles? Neutral particles or charged particles? Charged particles. Right. Clear now? Deviation of canal rays according to Fleming's left-hand rule. Deviation of canal rays according to Fleming's left-hand rule. Deviation of canal rays according to Fleming's left-hand rule. Deviation of canal rays according to Fleming's left-hand rule. Once a perpendicular magnetic field is positioned once a perpendicular magnetic field is positioned once a perpendicular magnetic field is positioned made Thomson understood made Thomson understood the fact that made Thomson understood the fact that canal rays consist of charged particles. Canal rays consist of charged particles. Made Thomson understood the fact that canal rays consist of charged particles. Made Thomson understood the fact that canal rays consist of charged particles. මෙවා charged particles වලින් හැදිලා තියෙනවා කියන එක understood the fact that canal rays consist of charged particles. Right. At last they realized these canal rays are consist of positively charged particles. How come? කොහොමද? They positioned an electric field using positively and negatively charged plates. Am I correct? So these canal rays would have deviated towards which plate? Positive plate or negative plate? Negative plate. The negative charge එකට attract වෙන්නේ මෙයාලට මොන charge එකක් තියෙනවද? Positive charge එකක් තියෙනවනේ. Out of then they realized that canal rays are consist of positively charged particles. Right? Consist of positively charged particles. Right? Clear now? Deviation of canal ray beam towards deviation of a canal ray beam towards negatively charged plate of an electric field. Negatively charged plate of an electric field. Negatively charged plate. Negatively charged plate of an electric field. Negatively charged plate of an electric field showcased that canal rays are consist of positively charged particles. Showcased that canal rays are consist of positively charged particles. Canal rays are consist of positively charged particles. Within brackets, you may use your red pen and write. Correct? This made canal rays to be called as positive rays or anode rays. This made canal rays to be called as positive rays or anode rays. This made canal rays to be called as positive rays or anode rays. Canal rays වලට positive rays එහෙම නැත්නම් anode rays කියන නම දෙන්න මේක හේතු වුණා. Positive rays or anode rays. Right. ළමයි, this is not necessary according to our syllabus. අපේ syllabus එකේ මේක වැඩක් නැහැ, but I'm teaching you this because I want my students to be very comprehensive when it comes to knowledge. හරිද? Formation of positive rays. I'll be teaching you how positive rays are being formed inside a glass tube. Right? Listen to me, Buddha. How positive rays are being formed inside a glass tube. Right? When we insert a gas and reduce the pressure inside the tube, right? අපි gas එකකට අපි tube එකකට gas එකක් දාලා pressure එක අඩු කරද්දී, right? What happens is the covalent bonds available within gas molecules will be dissociated at the beginning. A gas molecules වල දැන් hydrogen කියපුවම H atoms දෙකක් අතර තියෙනවනේ covalent bond එක. O2 කියපුවම oxygen atoms දෙකක් මැද්දේ covalent bond එකක් තියෙනවනේ. මේ gas molecules වල තියෙන electron share කරගත්ත covalent bonds කැඩෙනවා. ළමයි listen to me very carefully, right? Covalent bonds will be dissociated. කැඩිලා යනවා. Will be broken. Right. This dissociation of covalent bonds will result as neutral atoms. මෙන්න මේ covalent bonds වල dissociation එකෙන් මෙන්න මෙහෙම neutral atoms හැදෙනවා. Dissociation of these covalent bonds will result as neutral atoms. හරිනේ, hydrogen H2 molecule එකක තියෙන bond එක කැඩුනහම hydrogen atoms දෙකක්නේ release වෙන්නේ. atoms හැදෙනවා. Right. If we further decrease the pressure, අපි මේ tube එක ඇතුලේ තියෙන gas molecules අයින් කර high voltage එකක් electrodes වලට දීලා, if we further decrease the pressure, the attraction, I would say the electrostatic attraction between outermost electrons and the nucleus of these atoms, මේ ගැලවෙන atoms වල outermost electrons උයි nucleus එකයි මැද්දේ තියෙන ඒ දෙන්නගේ in between තියෙන මේ attraction එකත් කැඩිලා යනවා. If we further decrease the pressure, this attraction between outermost electrons and the nucleus of these atoms will be further dissociated. Right? Will be further dissociated, resulting positive ions and free electrons. මම මේ ඇන්දේ nucleus එකක් නෙමෙයි. දැන් මේ oxygen atom එකකින් electron එකක් ගියාම O+ ion එකක් නෙන්නේ, cation එකක් නෙන්නේ. Positive ions and electrons will be formed. හරිද පුතා? Right. May form වෙන positive ions, right? These positive ions, right? Look at this. So this process will be happening in between the anode and cathode. I would say this is anode and this is perforated cathode. I would say like that, will you? This is perforated cathode. Right? Perforated cathode. So once this process happens when the pressure is decreasing, right? So positive ions will be formed. Positive ions will be formed. Free electrons will also be generated. මේ විදිහට positive ions උයි free electrons උයි මේ මැද්දේ හැදෙනවා. හරි? හරි පුතා. මේ positive ions උයි anode එකයි same charge hinda, they cause attractions or repulsions when they have same charge. Repulsions. Cathode dekai positive ions we oppositely charge hinda, they imposes what? Attractions. Megollo aruwa tallu karනවා. අරු අදිනවා. Alright, as a resultant they move fastly towards the direction of this perforated cathode, right? මේ positive අය මෙයාලගේ repulsion එකයි මෙයාලගේ attraction එකයි හින්දා fastly move වෙනවා perforated cathode එක පැත්තට. move වෙලා they goes through these perforations. මේ perforations through යනවා. ගිහිල්ලා මෙන්න මේ පැත්තට දෙගොල්ලෝ. So this is the process of formation of positive rays inside a glass tube. මේක තමයි glass tube එකක් ඇතුලේ මේ positive rays formation එක කියලා අපි කියන්නේ. හරි? right, අපි මේ ටික නිකන් පොඩි note එකකට ගෙමු. These are external information. That's why I'm putting a note. Not formation of positive rays inside a glass tube කියලා තියෙන note කියලා තියෙන external note එකක් විදියට. So these are additional facts, but you may write these things. හරි? මේ knowledge එක වටිනවා. right. අපි මෙහෙම කරමු. මේ diagram එක ආය අඳින්න ඕනේ. We have the diagram in hand, right? The positively charged electrode, you must label it as anode. Positively charged electrode එක anode කියලා label කරන්න. This must be labeled as anode. The negatively charged plate, perforated cathode. It must be labeled as perforated cathode. Right. So some positive charged particles and electrons are there. Perforations through යනවා කියලා පෙන්වන්න. positive. ඒවා ටික පෙන්වන්න පුතා. ඔය white color එකෙන් plus කියලා තියෙන්නේ. ඒ තියෙන්නේ positive ions. minus කියලා තියෙන electrons. මට වඩා හොඳට ඔයාලගේ diagram එකේ ඇති. ඒක ලස්සනට ආයෙ ඕනනම් ඇඳගන්න. positive charge ඒවා මේකේ perforations through වෙනවා කියලා නිකන් පෙන්න ගන්න. right. ලියන්න. right. ලියන්න. paragraph එක යටින්. When we include a gas and reduce the pressure inside the glass tube, when we include a gas and reduce the pressure inside a glass tube, when we include a gas and reduce the pressure inside a glass tube, and reduce the pressure inside a glass tube, and reduce the pressure inside a glass tube, gas molecules will be divided into positively charged ions and free electrons. 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 Gas molecules will be divided into positively charged ions and free electrons. මේ තව පැරග්‍රාෆ් එකක් යටින් එන නිසා ගොඩ ලොකුට අඳින්න එපා පොඩියට අඳින්න right draw smaller මෙන්න මේ දෙක molecules කැඩිලා ඉස්සෙල්ලාම atoms එනවා atoms positively charged ions and electrons වලට further subdivide වෙනවා මෙන්න මේ diagram එක අඳින්න මේ දෙක චූටියට අඳින්න පුතා right draw as small as you can. ලියන්න You have the diagram in our hand, so you may write down. Speedy movement of these positively charged ions, speedy movement of these positively charged ions speedy movement of these positively charged ions through the holes of cathode will result speedy movement of these positively charged ions through the holes of cathode speedy movement of these positively charged ions through the holes of cathode will result in positive rays. Will result in positive rays. You agree with me, right? Will result in positive rays. Positive rays හැදෙන්නේ මේගොල්ලන්ගේ මේ faster movement එකත් එක්ක තමයි. Will result in positive rays. හරි, මම normal note එකත් එක්ක ඉස්සරහට යනවා. As the third step, right, during the third step of this electron, what do you call the canal ray analysis research, right? As the third step, Thomson and his team calculated the E upon M ratio of positive rays changing material of the cathode and gas filled in the tube. උදාර cathode rays වලට කරපු දෙයම Thomson යාගේ ටීම් එකයි මේ characteristics ටික identify කරගත්තට පස්සේ positive rays වලටත් කරනවා. මොකද්ද? They changed the cathodic material and they changed the gas inside the tube. And they observe the charge upon mass, which is E upon M ratio of these positive ray particles. So nitrogen dala N plus addi E upon M balno. Oxygen dala O plus ions positive rays vidiyata flow වෙද්දී E upon M balno. Hydrogen dala H plus ions යනකොට E upon M balno. E upon M figures මේ value එක බැලුවා at different stages. Then they observed that the E upon M value changes when the gas filled in the tube is changed. මෙයාලට දැක්ක අර වගේ constant එකක් නෙමෙයි එන්නේ. The E upon M value changes. The change in E upon M value when the gas inside the tube is changed. මේ ඇතුලේ fill කරන gas එක වෙනස් වෙද්දී E upon value එක මොකද උනේ? වෙනස් වුණා. The change in E upon M. Highest E upon M value obtained when hydrogen, which is the lightest gas, is used in the tube. Right? මේ tube එක ඇතුලේ ලෝකේ තියෙන lightest gas එක hydrogen දාලා H plus particles flow වෙනකොට positive ray particles විදියට highest E upon M figure එක ආවා. E upon M value was decreasing, and decreases than the above obtained value when other gases were used inside the tube. Hydrogen තියෙනකොට maximum figure එක ආවා. මේ ඇතුළට fill කරන gas අනික් ඒවා වෙද්දී nitrogen, oxygen, chlorine වගේ වෙද්දී N plus O plus Cl plus වගේ positive ray particles යද්දී E upon M values ඊට වඩා අඩු වුණා. පුතා, later in a minute time we conclude the fact that H plus particle equivalents to proton. H plus particles කියලා කියන්නේ protons වලට තමයි. හරිද? You know, hydrogen atom consists of one proton and one electron. What happens when electron goes away? It's simply a proton. H plus means what then? කියන්නකො ළමයි, talk will you please? Hydrogen atom consists of what? You know the structure of hydrogen atoms during your O-level days. Tell me, hydrogen atom consists of what? Talk, please. Hydrogen atom consists of what? A proton in its nucleus and an electron in its first energy level. Am I correct? What happens when H plus forms? H plus form වෙනකොට මොකද වෙන්නේ? That outer electron goes away. So it's simply a what then? H plus means simply a what then? A proton. H plus is equivalent to a proton. Both are similar. When hydrogen gas is included inside the tube, H plus particles, which are protons, moving in, we are getting the highest E upon M value. When other gases are included, N plus, O plus, Cl plus kind of particles are going through as the positive ray particles, the E upon M figure was less when compared to the H plus case. Right? Was less when compared to the H plus case. As the third step, Thomson and his team calculated the E upon M ratio of positive rays, changing material of the cathode and the gas filled in the tube. Then they observed that the E upon M value changes when the gas filled in the tube is changed. Highest E upon M value is obtained when hydrogen, which is the lightest gas, is used in the tube. The E upon M value decreases than the above obtained value when other gases were used in the tube. Right? So, you may write down, so the E upon M value of H plus particle, so the E upon M value of H plus particle, so the E upon M value of H plus particle within brackets proton, H plus particle means proton, right? Proton was comma, right. Puda kamamak dala api yatin lila kotu karamu. This has to be highlighted. Look at this. E upon value of H plus, which is proton, equals 9.575. This has to be memorized, into 10 to the power of 7 coulombs per kilogram. 9.575 into 10 to the power of 7 coulombs per kilogram. 9.575 into 10 to the power of 7 coulombs per kilogram. This is the E upon M figure of proton. Right. Moving into the next page. Later, Rutherford explained that the reason for obtaining lesser E upon M values when using other gases is mass of the positive ray particles in the presence of other gases is a whole number multiplication of the mass of a H plus particle. Right. Lamai Rutherford right? Rutherford told the lesser values of E upon M figure when the other gases are in presence, anik gases තියෙනකොට E upon M figure එක අඩු වෙන්නේ ඒ gases වල මේ particle එකක mass එක මේ H plus particle එකක mass එකේ whole number multiplication එකක් වෙන හින්දා කියලා. You know, when a fraction is there with a numerator and denominator, what happens when the value of denominator increases? Denominator ke value එක increase වෙනකොට මොකද වෙන්නේ? The fraction, is it going up or going down? The value of fraction becomes lesser. Am I correct? Right. So other gases වල N plus, O plus වගේ positive ray particles වල මේ mass එක H plus particle එකේ mass එකේ whole number multiple එකක් 7 times 8 times ඒ වගේ whole number multiple එකක් වෙනවා. ඒ හින්දා තමයි ඒ positive ray particles වල E upon M ratio value එක H plus ඉන්නකොට තියෙන E upon M value එකට වඩා අඩු වෙන්නේ කියලා Rutherford අඳුරගත්තා. ඒතකොට අනික් elements වලත් whole numbers වලින් තියෙන මේ H plus particle එක basic particle එකක් විදිහට identify කරගෙන ඒකට proton එක කියන නම දුන්නා. හරි? particle, this H plus particle is named as a proton. This H plus particle is named as a proton. Right. පුදා ඔතන කලින් page එකට එන්න. හරි කලින් page එකට එන්න. ඒ කියන්නේ page number 4 වල paragraph එකට පොඩ්ඩක් එන්නකෝ. As the third step, Thomson and his team නෙමෙයි. It has to be changed. Rutherford and his team. Thomson and his team කියලා as the third step. Thomson and his team කියලා කියන්නේ it has to be changed. Rutherford and his team. Rutherford තමයි මේක කරේ. Right. H plus particle is named as proton. Right. As atoms are neutrally charged. ඇත්තනේ නේද? Atoms වලට charge එකක් නැහැනේ. As atoms are neutrally charged. Magnitude of the charge of a proton is same as that of an electron. Mass of the proton is calculated using E upon m value and the value of charge. Right. So the E upon m ratio figure of H plus ions or else a proton is this. Right. We know atoms are neutrally charged. Atoms has no charge. No, atoms have no charge. Atoms වල charge එකක් නැහැ. ඒ හින්දා මේ scientists ලගේ logic එක උනේ මේ proton එකේ charge එක sign එකෙන් plus විදිහට electron එකේ charge එකට opposite වුණාට even though this has opposite sign, the magnitude of the charge of a proton must be equivalent to the magnitude of the charge of an electron. Electron එකේ charge එකේ magnitude එකට මෙයාගේ charge එකේ magnitude එක සමානයි කියලා logic එකක් ආවා. එතකොට අපි ලියුවොත් එහෙම E must be what then? E of a proton must be what then? E is same as 1.602 into 10 to the power of minus 19 coulombs, right? E must be plus, right? 1.9. Make up idamu. Wait, one second. Using this E upon m figure and E figure, the mass of proton can be calculated, right? Mass of a proton was found to be 1.673 into 10 to the power of minus 27. Using these two figures you can try at home. Kilograms, which is, this also memorize, 1837 times mass of an electron. Electron ke mass එක වගේ 1837 times වෙනවා. 1837 times වෙනවා. හරි මේ figures දෙක ලියලා කොටු කරන්න. යට තියෙන ඉඩේ you may write down these two figures. E of a proton equals 1.602 10 to the power of minus 19 coulombs. Mass of a proton is 1.673 into 10 to the power of minus 27 kilograms, which is 1837 times of mass of an electron. 1837 times of mass of an electron. Right. Leisurely read the subtopic C, positive rays and proton. Leisurely read it, Puta. Subtopic C, positive rays and proton. Leisurely read, will you? Positive rays and proton. You have enough time. Leisurely read it. Positive rays and proton. Now you have little things to be studied, right? Adane api islam syllabus එකේ වැඩ ටික පටන් ගත්තේ. Last day we were discussing about mole, නේ? එතකොට මේ am I moving faster? No. shape ni, everything is manageable ni. You know, it took about 2 weeks in our single medium class with 1,000 and or plus students to finish off these 3 subtopics. It took about 2 weeks, but I did it in 3-hour session for you. That's good, right? That's good. The speed is really good if it is fine with you. Is it fine with you? Okay. Right. Guys who are in the live, lamai mata live එකේ ඉන්න අය කියන්න, I need your responses. Was everything very clear? Right. Sir, are cathode rays always green and white? No, cathode rays are colorless. Once they collide in glass surface only, they give us the green color illumination, no fluorescent. They are colorless. So if cathode ray is formed in a vacuum, how did Thomson experimented it with different gases? No, it is not formed in a vacuum, Putta. When the pressure is less, still a little bit of gas molecules are there, then they realize these cathode rays, right? So it's not a vacuum. There are certain little amount of gas molecules available within the gas tube. Right, guys, tell me, is everything clear? Is everything clear? I need responses from everyone. Was everything very, very clear for you? Okay. How was the class? Okay. How was the session then? I covered 3 subtopics: introduction, cathode rays and electrons, positive rays and protons. Was it nice? Right. How was it for you? Understood everything? Perfect. Right. What do you want me to do? You want me to tell you a lot of life lessons and other stories and stuff like that, or can I continue like this? This is my way, that's why I have, if I need to adjust, I can adjust. You don't need to get 1,001 advices per day neither. Oh no, you don't need those bullshits, no, right? So we'll move like this, right? So I hope you understand things. I hope you are getting things. Anyway, for the physically attending students, after the class you can ask anything and clarify. For the live people also, there are hundreds of live people. For you guys, I'll be conducting in this way. You can ask anything. Ask from NJ is always open when I'm conducting live sessions. Right? So 3 subtopics was covered. ඊළඟ subtopics 3 මම ඊළඟ දවසේ cover කරනවා. මම කිව්වේ 3 months තමයි මට මේ lesson එකට යන්නේ. අද ඔන්න first class day එක ඉවරයි. second class day එකේ මම මේ history of atomic structure කියන chapter එක ඉවර කරනවා. So listen to me. We have to study about discovery of neutron, subtopic D. Thomson's plum pudding model, subtopic E. Rutherford's nuclear model, subtopic F. ඔන්න ඔය subtopics 3 මම ඊළඟ දවසේ cover කරනවා. So it's not that easy. Wait. එහෙම ලේසියෙන් ගෙදර යවන්නේ නැහැ. You have to do your homeworks. හරි? Right. මෙන්න මේ workbook එකේ, right? Workbook එකේ first 3 pages until question number 18 you have to complete. පළවෙනි pages තුනේ question number 18 වෙනකන් කරන්න ඕනේ. question number 1 to 18. මේකෙම answers ලියන්න, no worries. short answers are enough. question number 1 to 18. ඔයාලට මේක මේකේ ඉඩමදි වෙයි කියලා හිතනවනම් වෙනම කොලයක් ගන්න. අර මං කිව්වේ කොල 10ක් විතර clip කරලා තියාගන්න කියලා. question number එක දැම්ම answer එක ලියවා. ඒතකොට term test එකක් වගේ ලඟ වෙද්දී ඕනනම් මේක ලියන්න පුළුවන් නේ. That's better. You can use a separate answer sheet, whatever. Question number 1 to 18. First 18 questions in first 3 pages. Right? Not done yet, not done. In this past paper question book, right, PPQ book, so make it puta, I'm very systematic and high quality. Listen to me. You did everything under chapter 1 today. So questions in the workbook is also classified under chapter 1. Workbook එකේ chapter 1 වලට classify කරලා තියෙන්නේ. මේකේ chapters වලට classify කරලා තියෙන්නේ. ඒතර chapter 1 එකේ content එකෙන් last 25 years වල තියෙන past paper questions මෙතන තියෙනවා. ඒතර දැනට කරපු subtopic තුනෙන් you can do question number 6, 7, and 8. Question number 6, 7 and 8. 6, 7 is not related to the A level, it's basically related to the O level science. Only question number 8 belongs to the content we covered today. But anyway, past paper book එකේ chapter 1 වල question number 6, 7, 8 is your this week's homework. ඊළඟ workbook එකේ page 1, 2, 3 වල first 17 questions becomes 18 questions. No? First 18 questions becomes your homework this week. Right. Listen to me. Not done yet. Right? You're not. It's like this for the මෙන්න මෙහෙම තමයි study කරන්නේ, right? I'll be explaining you the mode of studying, right? Method of studying, I would say rather. හරි ඔයාට මම අද උගන්වපුවා අදම you take 10 to 15 minutes today itself and just go through. හරිද? මම මේ first week එකේම you please follow my instructions because I did it properly. I became island 11th, district 2nd. It means a really huge achievement when it comes to A levels. Becoming island 11th means a huge achievement. Plus my student became island first last year. You know those things. So as a lecturer and as a personal character, I have achieved whatever the topmost things had to be achieved when it comes to A levels. So you can trust my words, and I'm very committed to the subject as well. Hurry, take 10 to 15 minutes, a very short time today itself, and go through whatever the things been taught. You don't need to do your homeworks, no short notes, nothing. Just went through whatever the things been taught. It only takes 10 minutes. That's enough for today. During the midway of this week, let's say we are meeting on next Friday, no? Maybe Tuesday, Wednesday, Monday, Tuesday, Wednesday, like whenever it's free for you, take 1 to 2 hours, study these things thoroughly, right? Do your expected homeworks and finish off a comprehensive study of what you learned today, right? Before coming on next Friday, maybe Thursday evening or Friday morning, take another 10 to 15 minutes and go through what we did today. Understood? So it's called 3-step method. Which method is it said to be? 3-step method. You are studying whatever the things being taught 3 times in between 2 class days. Am I correct? Today itself, maybe Monday, Tuesday or Wednesday, midway in the week, Thursday evening or Friday morning before coming into the class. Midway session is a lengthier one. You do your homework and all the other stuff, making short notes and every stuff being done there. Today session and the Friday morning or Thursday evening, the last recap session is a very short one. Just නිකන් උඩින් ටට්ටක් ගාලා බලන් යනවා. හරි? That's all. තේරුණාද මම කියපු එක? ඒතර ඔය process එක follow කරන්න. ඒතර ඊළඟ Friday ඉඳන් ඊට පස්සේ Friday වෙනකන් yes, follow the 3-step method. Follow the 3-step method for the week after. ඒතර ඔහොම මේ weeks වල වැඩ ටික කරන් යන්න. ඒතර ඊළඟ week එකේ පුතා අර comprehensive session එකේ මේ weeks දෙකේම කරපුවා කරන්න ඕනේ. අර තේරෙනවනේ මම කියන්නේ ඊළඟ week එකේ තුනේම කරපුවා කරන්න ඕනේ. but කලින් ඒවා කරලා තියෙන ඉඳන් ඒවට එච්චර වෙලා යන්නේ නැහැ දැන්. හරි? ඒතර ඔන්න ඔය process එක follow කරගෙන යන්න, then you will be a genius. Right? I want you guys to rise and shine. I want you guys to be right at the top of the country and the respective districts of all your guys. So this is not an easy game, but this is very smart game. Working hard and awaking for long hours. හරිද? අර security job එකක් කරනවා වගේ රැලි නිකන් ඇහැරලා හිටියා කියලා ඉබේ මේක පාස් වෙන්නේ නැහැ. That is not. We have to be very smart. Working smart is the way of escape. හරි මේකෙන් අපිට escape වෙන්න තියෙන way එක. So those are the things. I hope you had a good session, right? I personally enjoyed a lot having spent some time with you guys. So this is it. So see you on next. Wait one second. Not letting you go. Right? We are meeting on next Friday sharp at 2:30. 2:30 to 5:30 is our time slot. Right? Please convey the message among everyone. Right? මම online ඉන්න ළමයින්ට කියන්නේ පුතා ඔයාලගේ district වල, ඔයාලගේ cities වල, ඔයාලගේ province වල ඉන්න ඔක්කොටම message එක convey කරන්න. because අපේ class එකට පරක්කු වෙලා join වෙන්න බෑ. we are going ඉක්මනට. අපි නිකන් හැම්මෙන් බොරු උපදූ පරවමේව කතා කර class වල we are not spending time no. So we are moving very quickly. ඒතකොට තව සති දෙක තුනක් යනකොට මේ තියෙන ලංකාවේ තියෙන ඔක්කොම ඉංග්‍රීසි මීඩියම් ක්ලාසස් වලට වඩා අපි එහාට ගිහිල්ලා තියෙයි. We are moving very fast. හරි. ඒ හින්දා මේ කට්ටියට join වෙන්න කියලා කියන next Friday වෙද්දී මේ ටියුට් පැක් එක හැමෝගෙම අතේ තියෙන්න ඕනේ. We have to move further. ඊළඟට ෆිසිකලි ඉන්න ළමයි ටිකට මම කියන්නේ ඔයාලත් මේ කුරුණෑගල වටේ ඉන්න සියොන් එකට මේ ෆ්‍රයිඩේ ඉවිනිං ෆිසිකලි එන්න පුළුවන් ඔයාලගේ යාළුවන්ට කට්ටියට මැසේජ් කරන්න. You just check. හැමෝටම මම කියන්නේ ඔන්ලයින් ෆිසිකල් ඔයාලා ඔක්කොම මම කියන්නේ check the materials your other friends got to first lesson. වෙන වෙන classes වලට ගියපු ඔයාලගේ යාළුවන්ට first lesson එකට හම්බෙච්ච materials බලන්න. මම කරන තරම් questions තියෙන workbooks තියෙනවද? properly classify කරපු questions තියෙන past paper question books තියෙනවද? ඔය quality එකේ well organized tudes තියෙනවද බලන්න. See whether they are familiarizing with these animations and some මේ වගේ visual aids අර වගේ මේ වගේ ඒගොල්ලන්ට දේවල් හම්බෙනවද? හරි? මෙච්චර clarity එකක් තියෙන note එකක් තියෙනවද? ඔය ඔක්කොම check කරලා බලන්න. ඒකක්වත් අපේ standard එකට match වෙන්නේ නැති වෙයි පුතා. ඊළඟට island first අපේ ඉන්න ඒ range එකේ results තියෙනවද? ගුරුවරයාගේ profile එක මගේ එකට වඩා strongද නැත්නම් ඊට යටින්ද? ගුරුවරයාගේ ප්‍රොෆයිල් එකත් ස්ට්‍රෝං නැත්තම් රිසල්ට්ස් උත් අයිලන්ඩ් ෆස්ට්ලා අරගොල්ලෝ මේගොල්ලෝ නැත්තම් මැටීරියල්ස් උත් ඔය දෙන තරම් ක්වොලිටි මැටීරියල්ස් ඔය දෙන විදිහේ process එකකුත් නැත්තම් they are not going to end up at the proper place. ඒගොල්ලෝ හරි රිසල්ට්ස් වලින් ඉවර කරන්නේ නැහැ. ඇයි? ගුරුවරයා ක්වොලිටිත් නැත්තම් process එකත් හොඳ නැත්තම් රිසල්ට්ස් උත් නැත්තම් it's a null. එතන ඇති දෙයක් නැහැ නේ. තේරෙනවද මං කියන්නේ? physically එන අයට මම කියන්නේ ඔයාලගේ යාළුවන්ගේවත් එක කම්පෙයාර් කරන්න උන්ට කියන්න අපේ process එකේ පණිවිඩේ. Please convey the message among everyone. And all island students also, I need you guys to convey the message thoroughly as well. Right? Right. So we are finishing, we are winding up the session for today. See you on next Tuesday, 2:30 p.m. Right? Right. Have a nice week then. Enjoy your time. Go safely. Right. Cheers all. Cheers.